refreshing break after an insightful day one of ICRAHOR 2026. It is wonderful to see such enthusiastic participation as we begin day two of this conference. We now move forward to our first session of the day, session three, post-harvest management, value addition, and zero waste horticulture, a theme that plays a crucial role in ensuring sustainability and reducing losses in horticulture. To carry forward the theme of this session, I invite our session coordinators, Dr. Gautami Sivaswamy and Dr. Nishan Kumar, to kindly proceed. I will also like to invite our reporters, Dr. Kartikal and Dr. Garima Thakur, who will be documenting the proceeding of these sessions. Over to you.
Thank you, Dr. Devi, for the kind introduction. Now I would like to call our session chairs and our respected dignitaries to please come on to the dais. Nutin ma'am, please. A very good morning to all the distinguished dignitaries, respected speakers, and dear participants. It's my privilege to welcome you all to Day 2, Session 3, Post-Harvest Management, Value Addition, and Zero Waste Horticulture of the 3rd International Conference on Recent Advances in Horticultural Research. Ram Asre sir has joined us now. I'm Dr. Gautami Shivaswamy, Assistant Professor at the Amity Institute of Horticulture Studies and Research, and I'm serving as the session coordinator for this session. It's a pleasure to be part of today's proceedings. This session is particularly significant as it addresses one of the most critical challenges in horticulture, that is post-harvest losses and its resource efficiency. With nearly 1/3 of horticultural produce being lost or wasted, the focus on post-harvest management, value addition, and zero waste approaches is not just relevant but essential for ensuring food security, enhancing farmer income, and promoting sustainable agricultural systems. Today's session will bring together innovative strategies, technologies, and practical insights that aim to transform waste into wealth and improve the overall efficiency of the horticultural value chain. Now we shall proceed with the session and begin by welcoming our esteemed speakers. It is my great honor to introduce our session chair, Dr. Jamilur R. Ansari. He is scientist at Yonsei University, South Korea. He brings over 18 years of academic and research experience, having previously served as Associate Professor of Physics at DCE Gurugram and PDM University. He obtained his PhD in Physics with specialization in nanotechnology from Guru Gobind Singh Indraprastha University. He has authored over 70 peer-reviewed publications and has contributed as editor of 2 academic volumes as well. His work has been widely recognized internationally through invited lectures at institutions like Qatar University, National Research Foundation of Korea, and American Chemical Society. Dr. Ansari's research focuses on next-generation food packaging solutions through advanced functional materials, including MXenes, perovskites, two-dimensional materials, and quantum dots, with applications spanning food preservation, sensing, and sustainable technologies. He also serves as associate editor for reputed journals and is actively mentoring 15 postgraduate as well as doctoral scholars. It's a privilege to have Dr. Ansari to chair our important session today. With this, I warmly welcome everyone once again and look forward to an insightful and engaging session. I now request you, Ansari sir, to kindly deliver your opening remarks. And also introduce the keynote speakers and take forward the session.
Good morning, everybody. Myself, J.R. Ansari. I'm basically associated with Yonsei University, and there I'm working with 0D, 2D, in fact, metal organic framework is also there. So we are basically incorporating all this within the polymers and trying to enhance the shelf life of the food packaging materials. And we are open for collaborations from MIT universities as well. Okay, so let's start with, here we have Professor Ram Asher sir, and he has started his professional career at Central Institute of Post-Harvest Engineering and Technology, Ludhiana. Presently, he is working as a principal scientist and professor in the Division of Food Science and Post-Harvest Technology at ICAR. Dr. Asre has made significant contribution in the field of pre- and post-harvest management of horticultural crops. His major work includes post-harvest handling protocols for strawberry packaging and transportation, pomegranate fruit bagging, low-cost de-shipping sanitizers for mango fruits, standardization of ethylene doses for commercially imported mango varieties, UVC assisted treatment for shelf life extension of fruits and vegetables. He has guided 13 PhD students as well as 10 MSc students are also there, and he has authored 2 textbooks on post-harvest management. He is the recipient of several awards and recognition, including ICR IARI Best Teacher Award, SK Mitra Gold Medal. Dr. Asre is the Board of Studies member of 5 Central Agricultural Universities, along with editorial members of 4 SCI journals. Now, I would request Professor Asre to start his talk. Sir, please.
Good morning to you all. Honorable Professor Kaushik, Dr. Ansari, my colleague Dr. Salni Gaur Rudra, Dr. Sitting in the front row, and my dear students. It's my proud privilege to be here in this morning. And of course, I have very long association with this MIT University in terms of my personal commitment and contribution. Alongside some of my students are serving this institute. That's a privilege for us. So not no, UVC. Bring that pen drive. है मेरा दूसरा टॉपिक है ये चलेगा इसको कॉपी करूँ वो पहले तो पढ़ा होगा आपके पास इसके UVC this one onto this first one yeah. Sorry for interruption. In fact, the topic allotted me is to harnessing the effect of ultraviolet C in quality retention and shelf-life extension of selected fruits and vegetables. Since a couple of years, we are working on this aspect, and it's giving very good results, keeping the fresh produce wonderful in the supply chain. It's a very huge practical application in days to come. Of course, still it's being used by different stakeholders. So let's have the glimpses of this aspect. I'll not go much more in introduction. And UVC radiation is type of UV light with the wavelength range of 200 to 180 nanometers. Of course, this range is doing well for keeping the fresh produce, you can say, alive for longer period. It's extend the marketability as well as it retains the health benefic compounds for long and duration. And of course, there are the different wavelength as I indicated. At the bottom, you could see UVA, that's ranging from 320 to 400. UVV, that's 280 to 320 nanometers. And UVC, that's at the lower sides, doing well for the preserving benefiting compound in fresh produce. So I'll not go in history. It started, of course, in the year 1801, and now we are in 2026. Since then, lot more it's a variant application have been occurred in the society in different form. So why we are using this technology? So benefits are there, of course. So we have to have the harness those benefits for gainful utilization in science and society. Uh, so it have some of the qualities like chemical free, eco-friendly, non-thermal methods, and safe for consumers, along with effective microbial reduction, quick treatment time, and a low operational cost, no resistant development. So all these you can say treats make its unique technology for application in fresh produce as well as processed produced handling. And UVC treatment for fresh produce safety assessment. Of course, it's very safe if you are using in right way at right time on the right produce. So it is a win-win situation for human health, food quality retention, and of course environment protection. uh, it affects different quality parameter in different way. I have highlighted over here how it's go about color, texture, weight loss, appearance, surface decay, and all this phytochemicals parameter retention. So a lot more bugs have been happened. You could see very recently, right from 22, 23, 25, 26. Lot more you can see. If you see any fresh produce handling journals, most of the articles are coming on this very topical issues or this unique technology. So major challenges of UVC treatment on produce quality, that's the low penetration. Only surface utilization is did. You could have seen the surface utilization during Corona time, how it was used in different way for sanitizing different, you can say, a product, and of course the living space and hospitals everywhere it have been uh, gainfully utilized in sanitization process. And if you go downside, equipment limitation, inconsistent treatment. Of course, this is the biggest, you can say, challenge. Of course, in last 5 years, lot more prototypes have come up for treatment of the fresh produce and other processed product. But still, some you can say low cost gadgets have to come for the end users for treating the fresh produce. And commercial status of UVC in food industry, fresh and processed. You could see widespread is the application like surface disinfection, pathogen reduction, extended shelf life, preservational value, so on, so forth. It's equally good for processed product also. And global uses and regulatory landscape of UVC for food preservation. You could see United States is using, and India, of course, India Pacific region. FSSI have framed the norms how this UVC can be used in different product sanitization. Brazil, European Unions, and China, of course, in all they are using and formulated the guidelines how it can be used safely for treating different food items and other things. UVC manufacturers in India, as I told you, that's it's a very upcoming technology, and a lot more companies are coming for making low-cost gadgets, so it can be utilized in different arenas of agricultural and non-agricultural, you can say, areas. So high-tech UV, APL, UV Heal, Super Cure, and MSI Scientific, they are manufacturing different gadgets and different types of UVC equipments. You could see how it can be used for treating different items. Of course, if you see at top left-hand corner, this machine is very useful for treating the fresh produce. Indian companies, they are manufacturing, but this unit cost of this machine is very high. This is 25 lakhs, of course, for a small, you can say, user, or any vendors or anyone who want to treat 4 or 5 quintals of their produce per day. So costly for them. So I think it will bring down, it will come down in days to come. Of course, once it's, you can say, scaling up goes, the cost of manufacturing of machines also comes down. Studies on coming to, especially, I am showing my work where our student, we have to do work. So I want to show, and it have given a very good result in capsicum. Capsicum, we have treated this capsicum with UVC and stored, and you can say studied different physico-chemical parameters. So it upregulates most of the desired parameters, and inhibits some non-desirable activities of enzyme or catabolic anabolic process. So very useful, and we inferred that 8 kilojoule per meter square. Yeah, this use of UVC giving better results in terms of in capsicum. These are some of the their SEM and this transmittance. So that confirms this very useful in keeping the cell wall intact, and this bringing down the other biochemical parameters at low space. Of course, their effect on suppressing the harmful enzymes, which we are not looking for to have their higher activities during storage. They are suppressed with this range of UVC. That's 4 to 5 kilojoule per meter square, and of course other uh, proline content is high. That's the desired, and other enzymes, especially the PG, PME, they are going down. So this is the pictures how the fruits like looks alike after 20 days of storage, and you could see this 4 kilojoules at even the 20 days. The fruits are looking a very good condition. Their cosmetic appeal is wonderful. So these are the salient finding I already narrated over there. And another work that's on guava. So we also attended the guava fruits. Uh, Basically, it's a use in guava, especially suppressing the fungal pathogen which are causing the rot in guava during storage. That's very effective, especially sanitize choledotrichum and Rhizopus stolonifer, and the fruits were stored for higher duration. Of course, this enzyme activities of this PME, and that's brings drastically down. So the browning of the guava is very slow. So that's, you can say, added benefits. We have measured different quality parameters in terms of inhibition of this fungal growth. So that have been shown over here. And of course, the mycelial growth, how is going to be checked. So if you could see, if you are increasing doses right from 4 to 10, that's going to suppress. But it's a giving equal effect. So I will go drop down if it's giving good results at 4 kilojoule per meter square. So these are the pictures of the guava, how this colotycum was suppressed. Outcome investigation, already I have told that's 4 to 6 kilojoule gives very better results. Even this results start coming from 2 kilojoule for suppressing these two very noxious fungi, as anthracnose causing and soft rot causing enzyme. Fungi, they are going to be suppressed even 2 kilojoule per meter square application. So of course, these are other findings. Of course, we did also some in combination with other elicitors. If we combine the melatonin with this UVC, your results are further appreciated. Means you can have the better results in terms of their physicochemical quality parameters, vitamin C retention, especially in guava, and this pectin polymerization is very slow if you infuse these two treatments. So combinational use of these with other illustrators is further coming well. We did on papaya UVC application. So it's not the thumb rule that UVC is useful other fruits and vegetables. We inferred or concluded that any fruits and vegetables having the latex, like papaya have some milky latex or this sapota, so they are not doing well with this application of UVC. So you could see the ill effect. Even if this we are using 1.6 kilojoule per meter square, thus oozing out some gum-like substances or pitting is over there. So it's not doing well over there. In case of papaya, we concluded it. We also did on bitter gourd. Very wonderful results in bitter gourds. We have got it, and you could see the doses and the duration. So UVC 253 nanometer per meter square gives the better results, and this charantin retention, especially memordicin and charantin retention, is very high. It's a very useful compound for bringing down this you can say glycemic index or anti-diabetic properties of the this bitter gourd because of memordicin and charantin. So their retention is very high if you are using this technology, and of course its seed hardness becomes slower down in comparison to control one. So you can retain the quality, store this quality bitter gourd for longer duration, even the 20 days by giving the different UVC treatment, especially the UVC. So these are some of the beneficial effect, how it's bringing down the decay loss and UVC exposure up. So how this melaldehyde accumulation and proline retention is going to be keep. So what should be the future scope of this technology? How we utilize in a better way? What's the way forward? Studies must be carried out to optimize UVC exposure time and distance from the light source. It's very important. That's why different machines, they are not working well. From how far we can expose, we should expose the material. So that's a very important. So all these nitty-gritty have to work out, and it's not thumb rule. Suppose that this UVC is working well for guava. So it not be quite obvious, it not be that much useful for papaya or okra. So mucilaginous containing material, they have different their reaction to UVC. So it have to be a work out for particular groups or latex bearing fruits or vegetable or mucilaginous fruits and vegetable. So others, you can say berries and roots, so on and so forth. So different approaches and different methodologies you have to work out for gainful utilization of UVC in frost produce handling. So this is in brief about my presentation. I want to convey that's a very useful technology, and especially the engineers and biologists, they have to sit together and you can see uh, develop some gadgets, very useful gadgets that can be cost effective. Even the small vendors or even the farmers, they can utilize. So that's, you can say, a message out of my presentation. So with this, I profusely thanks Professor Nutan Kaushik ji for giving me chance to put before my views in August gathering. Dr. Ansari is chairing the session, and my own colleague Dr. Salning or Rudra, and Dr. Saab sitting in front of the row, and very, you can say, very dear to me, the students of this university and faculty. So once again, thanks to one and of all for giving me patient hearing. Thank you.
Thanks, Professor Ram as well. It was a very wonderful and nice talk on UVC, basically how it basically enhanced the shelf life of the food product. Now the session is open for questions, if anybody is having. Yeah.
Okay, thank you. Dr. Saab, it was always a great pleasure listening to your presentation, and we always learn something new in every presentation. My question is that this UVC, what is the penetration? Suppose like the gamma radiation, we can pass through the truckload through the gamma radiation, and it can take care of the entire lot in the depth. So similarly, is there a device which can take care of the truckload? Then what is the depth up to which it works actually in the piles? When there's a pile of the fruits and vegetables and everything. So what is the depth at which it works? Till what depth?
Professor Kaushik, very interesting question, and as I highlighted, it's a limitation. That's the limitation of this technology. So a depth of any fruit and vegetable, this profile, it is not more than 15 centimeter. That's, you can say, biggest hurdle. So you have to have spread the material in single layer. So where the conveyor belts are rolling on, and your produce is conveyor belt application. So truckload like we do used to do in case of gamma irradiation, where we pass on our this potato or garlic or onion trucks through that, and that's a treated.
We do the conveyor belt application of this UVC. What kind of packaging it will require so that it remains effective till the entire supply chain?
So first you have to give the treatment.
Yes.
So that's the first step. After giving the treatment, whatever the way you want to transport it or pack to it, you have to do. But you have to have give the treatment in a conveyor belt system, means a single layer system. So after that, whatever the packaging material is immaterial, like treated or untreated, whether it's UVC treated or gamma irradiation treated, that doesn't make difference in after the treatment. How's the handling, how's the packaging, that doesn't make any difference.
My question is just like for how long this exposure remain effective, till what time?
Okay, so I have shown mostly in case of this papaya, we give up to 20 minutes. That's a higher side, but it's working well within 5 to 6 minutes. So you have to set the speed of the conveyor belt and distance. So while troubling your material, it should remain for 6 minutes. So suppose that you are setting this intensity 6 kilojoule per meter square. So 5 minutes at least you have to expose the material.
Thank you so much, sir.
Any queries from the audience? Yeah, please. Can we have a mic? Yeah.
Hello. Thank you, sir, for your nice presentation. Just I have a very simple questions. As you have mentioned, in case of the capsicum, so in my mind, it is arise for the capsicum packaging stories. Nowadays, the coating has been standardized. But my question is that coating at the time of the packaging, is it the stage for the capsicum will be the same for the green, red, and yellow?
Stage of harvesting makes difference, but the variety or group of color, red, yellow, or you can say uh, green one, that doesn't make. But stage of maturity, of course, make difference for all these three groups. If you are harvesting a very, you can say early stage, so that doesn't even allow immature this capsicum. Of course, people used to harvest the capsicum at very early stage, but at that stage there is no development of this wax. So waxy layer is, you can say, a very prominence waxy layer is with this capsicum. So when it develops, and of course after anthesis, I don't know you understand this term, anthesis, after pollination, after pollination 6 to 7 days, even.
So my question is that, as you know, like in case of the different color of the capsicum, green color of the capsicum after pollination, the color becomes very orange. But for the red and the yellow,
No. Let me know. There are three groups. Red, yellow, green. Green, there are some varieties. Suppose that California Wonder you are taking. That's a green, but at the ripening stage, senile stage, it becomes red also.
the California Wonder.
Yeah. If you leave it
In the very
later stage, it becomes red.
but consumer condition.
That cannot be consumer condition. So I'm not getting what you want to know.
I want to say, like in case of the red and the yellow,
Mhm.
the color development in the latter stages. So my question is that if the red and the yellow can be harvested in all these stages, because in the transport itself, the color development has been changes.
Of course.
So that is the reason. If we can fix the particular harvesting stages,
Already they are well documented. Already well documented. If you go package of practices of capsicum cultivation, so already for different varieties, the days are we can say harvesting stage already worked out. So if you are observing those guidelines and giving the treatment of UVC, it doesn't make a difference whether it's a green, yellow, or red.
thank you.
Okay, thank you. Any queries from the audience? Yeah, please.
Good morning, sir. Sir, I am Isha. Currently, I am pursuing my master's in horticulture. So, sir, I wanted to ask, sir, UV radiations are like harmful for humans. So, the people who are working in labs, it will be like causing any effect on that people or not?
Not such any reports that is going to harm anyone. If you are treating or observing the guidelines, it's not lethal that much. So while you are treating, you have to have observe the norms. Even if you are opening the chambers, you have to wear the gloves. You have to the peoples who are working nearby, they have to wear the specs. So some anti this UVC specs or glasses are there. So our guidelines is there. It's not that much lethal.
What sir is telling that when you have to apply the UVC, there are certain guidelines to handle the UVC.
Yeah.
And you have to follow those guidelines. If you follow those guidelines, it is not harmful.
Thank you, sir.
One microwave.
Sure. It's my pleasure.
So actually, UVC you are using. UVC you are using. Okay, you are basically using UVC radiations for cold storage kind of things. But suppose the product are in the market, in the open market, so there are chances that it may get exposed by the direct sunlight. So there we are having UVA or UVB radiation. So how to protect the food or how to enhance the shelf life in that conditions?
Sir, in my opinion, it's a very simple. You should not expose your produce. This is already we used to say that you save your produce from direct sunlight. So you, of course, if you go in our condition, in even the Delhi, people used to bend their fruits and vegetable along the roadside in the scorching sun, even the May, June. So that should not be. That should not be. And IITs and other institutions, they have developed some cards for vendors. So they have to bend their produce. Under that, you can say umbrella. They have not to expose their produce in open sun. Of course, if you are exposing the open sun, as you said, that's A or B or they are going to be harmed.
Okay. Okay. Thank you, sir, for your nice talk. Let's give him a big round of applause.
Thank you, sir. As I understand your question, I don't know, your question may be different, but of course, no. Always there we used to say harvest fruit in the morning hour and don't expose to sun. So that may be one of the aspect. I don't know if you have anything else. If I could not understand, we can discuss during that. Yeah.
Online configuration. Okay. Okay, sir. Please. Oh, he's connected. Okay. Okay, now we have Dr. Randolph M. Baudry from Michigan State University. And Dr. Baudry, he is a distinguished professor and post-harvest specialist at Michigan State University. He is having academic foundation. His academic foundation began at the Ohio State University, followed by an MS and PhD in horticulture from the University of Georgia. Dr. Baudry's research program involves the optimization of storage strategies to mitigate post-harvest disorders with a particular focus on apple and blueberry. He is recognized expert in control atmosphere storage, modified atmosphere packaging, and the development of non-destructive quality assessment techniques. His fundamental research delves into aroma compound biochemistry and its molecular regulation.
Dr. Rudolph, maybe some connectivity issue are there, so they might be connecting first.
Okay, thank you. Hey, Giancarlo.
Hey, Randy, I don't know if it's just you and me, but must be late over there. We
Yeah, it's
back,
late
huh?
and it's very early where you are. Yeah.
Well, not too early, like, yeah. I think it's better.
Yeah, I still got a night's sleep
And
ahead.
I can see that banana tree on your back is real because I see your reflection in the glass.
This is my tropical
Okay.
backset. Yeah.
It's not a fake one.
No.
It's
We
a
grow
real
these every
banana,
year.
a real banana. Oh, no, it's not a banana.
Yeah, it's banana.
It's a banana, yeah. A real banana in Michigan.
At some level, I'm interested in knowing whether or not they're hearing us chat, but I kind of like it too, for that matter. So, yeah. So, you doing well?
Yep. No,
Yeah.
I mean, I saw you've been in Thailand last week or 2 weeks ago.
Yeah, I may be following up on the work that I'll talk about today on mango. So we might be looking at a range of cultivars with different ripening characteristics and see just what kind of diversity actually exists in their germplasm. Yeah, it'll be fun. You must have seen Pirsak's
Well,
uploads.
actually, I saw him last October in Bangkok.
Oh, no, I mean, you must have seen him post. Sorry.
Okay. We're back.
Can't hear them. Looks like they're muted. There you go. Oh, and for what it's worth, File, maybe they can hear us, but Watkins was here last 2 days.
हेलो अरविंद मैं फोन से कनेक्ट कर रही हूँ एक बार पूछो हेलो
Hello.
हाँ Randy actually we are just waiting for the net connectivity here there's some issues in the net connectivity in electricity and we are resolving it I think it will take 2-3 more minutes sorry for about and sorry for making you wait your background looks pretty okay where are you in Sri Lanka or where
Because we should.
I'm in my own home. So we grow
Your own
bananas
home
every
with this
year. Yeah.
beautiful background with banana trees. Oh my God, very good,
Yeah.
very
Yeah.
lovely.
Since I'm talking about tropical crops, right? It's a good backdrop.
Oh, very good, very good, very good. Thank you so much. I'm sorry, Dandy, for keeping you awake till late night.
Yeah,
I
it's
must
pushing 2
be 3
o'clock.
a.m. now. Must be 3 a.m. now, huh?
2. It's
2
1:45.
a.m. Oh, okay, fine. Sorry for making you wait. Technology we cannot help. Okay,
Yeah.
so there are technological disruptions which we cannot help. Thank you, thank you.
Oh, you're welcome. Yeah, no problem. No problem at all.
I would give you some coffee, but I think you don't have
Yeah,
the
kind of the wrong time of day
to
for
talk.
that. It might be nice though, I would say, and especially Italian coffee. Are you in Italy?
Yeah, I'm home actually. So
Okay.
Oh, you are having discussion with the. Hello, Khalil.
hello,
Thank you for
hello.
joining, and we are because of this technological disruption. So
Well, yeah,
because
it
we can hear
happens.
you, but people will not be able to hear you because it will not go to the speakers. So we're just waiting for the restoration of the electricity.
Yeah,
The
it happens.
connectivity,
Usually it
rather
happens
connectivity.
on the best moment.
Yeah, thank you. I was hearing, I was like seeing that both of you are having nice discussions there. So,
Oh yeah.
Yeah, well, where else am I going to hear about
and-
pomegranates, honestly?
but I think within 2 minutes we should be ready. The light. Yeah. Okay. Thank you.
You're welcome. Giancarlo, I'm going to be in Italy in a week.
In a
Huh?
week? In a week?
You will be
I'm
in
talking,
India?
I'm going to be in Italy for a week, in a week
Oh,
for
in
2
Italy.
weeks.
Okay.
Yeah,
Good.
on vacation.
Good.
Talk to me later. Tomorrow, whenever you wake up,
Okay.
to see if we can plan some.
That's a nice confessing. So when both of you are coming to India?
I might come in a year's time.
In a year's time. Please keep some time for us also when you come.
Okay.
Both of
Yep.
you. I'm requesting both of you. And
Yeah, I actually never been to India so far, so
yeah, please,
it would
you're welcome.
would be nice. Yeah.
Welcome. You can come anytime, and we'll very happy to host you here.
I'm actually going to Thailand in 3 weeks.
When you are going to Thailand, just make a 2-day or 1-day break at India.
Yeah, do a layover in Delhi.
Yeah, well, but
Yeah,
still.
layover in Delhi for 1 day. 1 day is sufficient to, though it's not sufficient, but yes, meeting physically makes a lot of difference.
Yeah, well, we'll plan another time with a better
So
opportunities.
have you booked your tickets and have you made your finalized your plan?
Well, we actually finalized everything, so and
Okay,
the
good.
schedule is pretty tight. But there will be a
Come
chance.
dedicatedly only for us.
Yeah.
Okay, that's great.
Where are you headed?
Okay. We are just trying to. Thank you. That's a problem of the online mode. Offline, you can continue, but online, you have to wait for the connectivity.
Well, it was good right up to the moment. When I was
Yeah,
about to
it
call. Yeah. It's my electric personality, I'm sure.
कितना time लगेगा? So if you allow, Randy, can we start the offline talk which we have? We have a speaker here.
Sure. Yeah, that makes sense to get the
If you
session
allow.
on, keep on time.
We can start with the offline talk and then you can join later, huh?
Okay.
Oh, sorry for about that. So we have to, okay. So we'll starting with one more talk and then you can later. By that time, I think everything should be in order, and hopefully you would be able to deliver. Thank you.
Mhm.
Thank you for your patience. Thank you.
Can we have a chat while the session is going on?
You can have a what?
Dr. Koleli and I, can
Yeah.
we speak to each other while the session is going on? Maybe the answer is yes.
I don't
It can
know.
be done, I think. I don't know if people will be audible or not. Let me check with Nutan ma'am and then I will let you know.
All right, thank you.
Yes.
I mean,
Yeah.
probably the chat will not go into the room, but will be, all the people connected, I think, can hear us.
Okay, maybe we should just.
I think only the room is not connected.
Ah.
I think that's the way it is. Oh, now it's connected.
Dr. Shalini has been actively involved in several extremely funded projects from agencies like DBT, DST, ICAR, and MOFPI, focusing on nutrition security, functional foods, and farmer empowerment. Her contribution have been recognized through several awards.
Hello.
Hello, Dr. Baudry, can you hear us?
Yeah, I can.
Okay. So our next speaker, Dr. Baudry, is with us, and he's a distinguished professor and post-harvest specialist at Michigan State University. Dr. Baudry academic foundation began at the Ohio State University, followed by an MS and PhD in horticulture from the University of Georgia. Dr. Baudry's research program involves the optimization of storage strategies to mitigate post-harvest disorders. He is a recognized expert in controlled atmosphere storage, modified atmosphere packaging, and the development of non-destructive quality assessment techniques. His fundamental research delves into aroma compound biochemistry and its molecular regulations. Dr. Baudry's contribution to scientific community are extensive, comprising of 146 referred publications, 12 book chapters, and 15 patents. His global standing is reflected in his 2020 ranking with the top 2% of researchers worldwide. His career is decorated with prestigious honors, including being named as Fellow of American Society for Horticulture Sciences and receiving Fulbright Nehru Distinguished Fellowship. Dr. Baudry is a dedicated member and educator who has guided 26 masters and doctoral students as a primary advisor and served as over 130 undergraduates committee globally. With over 170 presentation to lay audience and 70 outreach articles, Dr. Baudry continues to play a pivotal role in translating complex psychological research into actionable strategies for the horticulture industries. Now we will welcome Dr. Baudry. You can start, please.
All right, thank you very much. Thank you very much, Dr. Kaushik, for the invitation. I appreciate that. It's nice to be almost in India again. I've been there many times, as you know, and part of the work that I'll be presenting today is on some of that experience that I had in India. So let's get started. I'll open up the talk here and we'll get going. So you can see this? I assume. Okay.
Not yet,
Uh,
not yet. Wouldn't say.
Okay. Let me know when the slides are up, please.
Not yet. We see two frames, which is you and the table. And the...
Dr. Badre, please share your presentation.
Okay.
Yeah, please.
Okay, maybe that's the problem. Thank you, thank you, thank you. Yeah, it's it's late. Okay. Does that look better?
Okay. Yeah.
Yeah, now it's okay. Please start.
Okay. Yeah, my apologies. It's a little bit late in the evening and I'm a little punchy. So the work I'll talk about today is on mango, something very important in India. You know, the Alphonse mango is extremely tasty and delicious and sought after mango fruit, but suffers from the inability for it to be shipped worldwide. So I did some work both in Thailand and in India that I'll be reporting on today that kind of explains why maybe our mangoes are so resistant to the kinds of treatments that we might give, let's say, bananas to achieve international marketing. So mango, climacteric fruit that refuses to play by the rules. So the first, I guess, point is to talk a little bit about fruit ripening and the history of the climacteric. So it actually goes back to some early observations back in 1909 on cherry laurel and tropelium leaves. And during senescence, they noticed that there was an increase in respiration of these plant organs. And then in 1922, two researchers out of the Malling Institute, Frank Kidd and Cyril West, described this rate of respiration of mature apples after gathering that increased until it reaches a maximum or a climacteric, then fell off. And then here are some copies of that early research and reports back in 1922 and in 1924, when they actually termed this rise in respiration as the climacteric, which you can see down here in their quote. So yeah, that's where it all began, I guess, in terms of beginning to understand the physiology, the post-harvest physiology of harvested fruits. In their early work, we found that there was an increase in respiration that was temperature dependent. So it's shown here. So here's a 22.5 degrees C respiratory rise, 10 degrees C rise, and then a 2.5 degrees C rise. But when you took these kinds of data and then you normalize them so that the minimum was the same, you can see that there's the rise in respiration relative to the pre-climacteric minimum is all about the same, independent of temperature. So it really shows you that this physiological drive is consistent and persistent across different temperature ranges. So at low temperature, when ripening takes place and those physiological processes unfold, they're basically the same as they are at high temperatures. So that's kind of the point that they made, but once again, characterizing the climacteric. And so after that work, we began to classify all of our fruits and some vegetables as either climacteric or non-climacteric. And what you see here are those classifications, and you see breadfruit, cherimoya, mango, the fruit of interest today, fig, tomato, and my beloved apple. And non-climacteric fruit are present as well, and you can see them listed here on the right-hand side. So one thing that you might say, and I can't see the top of the screen up here. Here we go. Maybe I'll move this out of the way. You can see that there are ethylene producers and non-ethylene producers. And so what began to happen over the many years between the time that these initial respiratory rises were described and those and the current day, we discovered that ethylene was produced by all of these climacteric fruits, or essentially all of these climacteric fruits. And then slowly the climacteric began to take on is sort of a role of being an ethylene product, I guess I would say, an ethylene response product. So if you think of climacteric fruits, most researchers would say that the climacteric is in response to ethylene production. Okay, so that's the backdrop. So the question then might be, if what people have observed is true, does the climacteric occur in the absence of ethylene? And in tomato non-ripening mutants, it does not. And when you apply inhibitors of ethylene synthesis or action, such as AVG or 1-MCP, you can knock out autocatalytic ethylene, an apple, banana, and then there is no climacteric for those crops. But the question is, is that true for mango? Does the mango behave? If ethylene is essential for the respiratory rise, are there times when ethylene action inhibitor 1-MCP fails to suppress the respiratory rise? If that's the case, then there's an alternate pathway for ripening that does not involve ethylene. So this is the question that we're approaching today. So I go back in time, some 22 years, where I was working in Thailand, and you can see Dr. Kosistrakun noted here, and then Nunchanak Nantachai, his PhD student. We worked together on a project where we looked at CA controlled atmospheres and then 1-MCP on the post-harvest physiology of Namdok Mai mango, pictured here. So we harvested the fruit, brought them back to campus, and then did our work. And Nunchanak found that to back up a little bit, we applied 0, 5, 10, 20, 30, 40, and 50 parts per million of 1-MCP. Now, Dr. Kaleli, who will be speaking in a little bit, surely understands the importance of this. That is that 1-MCP at about 1 part per million for almost every commodity will fully inhibit ethylene action and fully inhibit ripening, okay? But what we see here for these Namdok Mai mango is that basically within the range of variation, all of the treatments, all of the different concentrations of 1-MCP, up to 50 times the normal dose of 1-MCP, all ripened. They all ripened independent of the 1-MCP treatment. So here we are looking at ethylene production, and here we are looking at ethylene production here, and then internal ethylene production here. So it did not affect ethylene production. Skin coloration proceeded normally. There was no reliable effect of the 1-MCP on skin coloration. So in other words, the fruit changed color. And in terms of respiration, so the classic measurement, I guess I would say, of the climacteric, once again, there was no difference. So if you look at the 50 parts per million in the open circles, 50 parts per million, basically the same as the 0 parts per million, which is the solid circles here. So no effect. So this work was never published. I think Nunchanak was a little concerned that perhaps something was wrong with the experimental apparatus. But the work it still sits on my computer in terms of its data. And then a number of years went by. So from 2005 to 2023, when I re-engaged with this work, now in India with Indian varieties. So then I started working with Dr. Sangeeta Chopra at the Indian Agriculture Research Institute and her PhD student, Shivangi Niles. So we did this work, collected, I was in the United States. They were doing the work and collecting the mango fruits and then treating them according to a developed protocol that we had. But we would go back in the literature. There's a scientist by name of Stanley Berg and his wife Ellen Berg who did some work, and they showed that mangoes had an increased sensitivity after harvest. And they proposed that what happens is the sensitivity to ethylene goes up after harvest until it meets the level of ethylene in the fruit, and then that induces ripening. So what they were saying was that ethylene was the reason for or the cause of the ripening and then the climacteric. And they also did another neat piece of work where they applied a steam girdle to the stem above the fruit, and that induced the fruit to ripen on the tree. Otherwise, when the fruit were on the tree, they did not ripen. So we're looking at both of those observations of Berg in this particular work. So, okay, so the idea with that Berg proposed was that a mango fruit ripening should be driven by ethylene. And then I was doubtful because of the work in Thailand. So, of course, what do? You do the test. So we looked at two different cultivars, Amrapali and Pusamanahari. And then we treated and immediately we harvested those fruits, and treated them immediately with 10 parts per million of 1 MCP. And then we had some fruit that were left, control fruit that were left untreated, and then we compared those treatments. So, okay, yeah, the mangoes are harvested every couple of days, 3 days from 25th of May for up to 60 days. So this was not a small experiment, but rather a long-term continuous experiment. And then the fruit were treated with 1 MCP either once, or they were treated every day with 1 MCP. So we treated them in a container, vented, and then held that container overnight. We would vent the container the next day, treat them once again with 1 MCP, and do that for 14 days continuously. So this is the data. So the first thing we did was we evaluated density. We were told by a number of researchers, and I was told this in Thailand as well, that the density of the mango fruit will increase on the tree, and it's a good indicator of maturity. Well, that is just not true. So these are the data for both Arampali and Pusa Manohara. We determined the density of those fruits, and what you can see, while there's considerable variation, there was no change in the density of those fruits over the 60 days that they were on the tree. So these are mature fruit, held for 60 days and then no change. So yeah, so that's kind of an interesting point, I think, for us to take home. And that is that sometimes these belief systems that we have are not necessarily true. So that may hold for ethylene as well. So when we looked at the respiratory rise, we can see that there's a respiratory rise as soon as the fruit are harvested. So these dotted lines, these dashed lines indicate fruit that are harvested, and you can see over ensuing days, there's a decline in respiration, much like Berg showed, Kidd and West showed, and then an increase in respiration follows that. So in every case, you can see once the fruit are harvested, there was an increase in respiration. So very much in keeping with what we were expecting for the fruit to ripen. But that did not happen while the fruit were on the tree. And the same thing is true for bricks. You can see that the total soluble solids remains constant and stable. So the starch did not convert to sugars while the fruit was attached to the tree. And once the fruit were separated from the tree, you can see that there's a rapid conversion of the starch to sugars, and then that speed of that conversion increased as the fruit maturity increased. So the fruit were very definitely ready to ripen at this early stage, but they ripened a little bit on the slow side, and as time went on, they would ripen more and more rapidly. Same thing is true for the firmness changes. While on the tree, the fruit firmness declined slowly over those 60 days. You can see that the rate of firmness decline was much faster once they were harvested and removed from the tree. The case of internal coloration, the same story, I guess I would say. There's a slight shift in internal coloration over time, but really the most rapid change in internal coloration took place once the fruit were removed from the tree, whether it would be Pusa Manohara or Arampali. They behave the same. So the data suggests that as Berg suggested, there is a tree factor, something on the tree that inhibits inhibits ripening. The nature of this inhibitor that's in the tree is unknown. Avocados share the same sort of behavior, but it may be a really interesting area of research, whether it's just simple sugars being imported into the fruit or it's some other signal coming from the tree is unknown, but it certainly deserves some kind of a follow-up. Okay. So once we remove those fruit from the tree, some of those fruit were treated with 1 MCP. So you'll see that here, and see there's a brown line here, and then a pink line here. So the pink line was those fruit treated with 1 MCP, and you can see that treated with MCP, which normally would stop the ripening of banana forever, it would stop the ripening of pear forever, it would stop the ripening of apple for probably 2 months. So the 1 MCP treatment had absolutely no effect on the ripening of these fruit. The exception here is a continuous 1 MCP, but I don't know but what this is, maybe some errors in measurement, but I'll leave it at that. You'll see why I say that in a moment. So no effect of 1 MCP on the respiratory change. When we look at Arampali, basically the same thing. So here's our MCP treatment here. Maybe there's a slight delay. Maybe not, but what we do see is that there's ripening even following the 1 MCP treatment. And when we look at total soluble solids changed very rapidly on the 1 MCP treated fruit. That's the orange dots. And the yellow dots here is a continuous 1 MCP, absolutely no effect of the 1 MCP. And I'll just go through these slides relatively quickly here to try to catch up for time. But what we see for arm poly is the same thing for soluble solids. When we look at firmness, the 1 MCP treatment, again, orange here and yellow, no effect for Pusa Manohari, and once again, no effect for RM poly with either a single or a continuous application of 1 MCP. They still softened. Internal coloration, you can see that the 1 MCP, single or continuous, had no effect on ripening. And then this is the only statistically significant note here, and that is internal color was slowed a little bit by the continuous treatment for the RM poly fruit. So in contrast to what Berg suggested, it's not necessarily a post-harvest increase in sensitivity to ethylene. There is apparently a non-ethylene dependent pathway that enables ripening in mango. They are insensitive. Once we desensitize them to ethylene, they still ripen. So that's an important statement, I think. So mango, it's an unusual climacteric crop. And as far as I know, it's the only one to be responsive to ethylene. So you can induce ripening with ethylene, but it's still able to ripen even when ethylene action has been completely inhibited. So this fact actually limits its ability to be shipped to distant markets. And if we could overcome this limitation, so to find a variety of mango that absolutely depends on ethylene for ripening rather than having the secondary pathway, then potentially anyway, we could have a mango that could be shipped to foreign markets and then induced to ripen in, say, banana ripening rooms and then delivered to the consumer. So that way you could get this worldwide distribution. But its behavior now prevents that from happening. And that's my take-home point, and I'll thank you for your attention, and I'm happy to take any questions.
Yeah, thanks, Professor Badre, for your very informative talk. Now, the session is open for questions from the audience. If you have any questions, please. Yeah, ma'am, please. Use this.
Dr. Baudry, it's wonderful to hear you and good to see the pictures of our campus. I would like to know two things. One, that the Julian days on the x-axis, they were quite a big range. So does that indicate that 7 months, until 7 months, you've been able to store the mangoes?
No, that was just the day until we made the measurement. So we measured at a particular Julian day. It was within the normal harvest season. And then the data itself indicate a storability of no more than 2 or 3 days, or 3 or 4 days, I guess, once the fruit were harvested. But on the tree, 60 days without changes. It was really very interesting to me. Yeah. And I don't know that this is true of all mango varieties. As we know, variety has a tremendous impact on ripening physiology and ripening behavior. But in this particular case, yeah, for those two varieties, we saw no change in density, no change in, very little change in firmness, no change in total soluble solids, and so on, while on the tree. Tells me that the best place for those fruit is on the tree. We even compared it to low temperature storage. And in terms of the early harvests, it was still better to harvest those fruit, to keep those fruit on the tree than to put them in cold storage. And as you got later and later in the harvest, then of course, cold storage would provide some advantage and allow you to ship the fruit for longer distances. But yeah.
Maybe we can advise the farmers to let it be on the tree until they are ready to transport and they have a market, and then like meanwhile they can bag the fruits. Can we give such?
I think that's what I would say. Yeah. If you're going to ship, then definitely put them in refrigeration, reduce the temperature to 14 degrees Celsius or something like that, a non-chilling temperature. But if you're not going to ship and you're just going to hold the fruit, I would keep them on the tree. And if you're going to market immediately after harvest, that would be a preferable way to manage it, I think. And until you get to the later stages where you want to slow things down, because the fruit at the later stages on the tree are senescing. they are senescing and they're susceptible to more decay and things like that.
Thank you so much. Thank you. It was a wonderful.
You're welcome. Nice to see you. Yeah.
Thanks, Professor. Yeah, we have one more queries.
Hello.
Hello.
Can you hear me?
Yes.
Really delighted to hear your challenging lecture. Since our student life, we have been following the Leeuwenhoek's theory in ripening of climatic and non-climatic fruits. But you have challenged most of the aspect. So I think all the community is waiting for your groundbreaking path to see the light of any publication. So what's your say on that?
So we have two publications that are out now on this work. The MCP work is not included in it, unfortunately. There was some communication problems, but we will be publishing the 1MCP work in the next year or so. I would also follow up and say that I'm involved in a project in Thailand where we will be searching for variants in the ripening behavior of mango. So looking for specifically for mango varieties that are slow to ripen, maybe more responsive to ethylene and have less capability to ripen in the non-ethylene pathway, if I could say it that way. So that holds some promise, I think. From what I know, when I talked to my colleagues in Thailand, that there's considerable differences in the rates of ripening. What they don't know is whether or not that rate of ripening can be enhanced by, let's say, an ethylene application, in which case that would be kind of exciting news.
Okay, I have mentioned the Pusha Manohari, one of the variety released from Indian Agricultural Research.
Yeah, that's exactly right. Yeah.
You conferred that the ethylene and the respiration rate, they are not going hand to hand. So means there is no positive correlation. So, but our basically all our works over here, it shows that a strong positive correlation with ethylene evolution and respiration rate.
Yeah, the ethylene is not autocatalytic. Oh, I'm sorry.
People in other mangoes also conferred or inferred that.
Yeah, so the ethylene biosynthesis in mango is different from other climacteric crops, as far as I know. It's not autocatalytic, as I understand it. So, in other words, it just creeps up, slowly increases like so. If you look at apple, the increase is on the order of 10,000 fold, something like that. And banana, kind of the same thing. Pear, the same. So there's this very sharp increase in ethylene production. Whereas in mango, it doesn't behave that way. It just increases. Respiration increases, but the ethylene increases as well. And like I say, when we shut down ethylene perception with 1-MCP, the respiratory rise still takes place.
Okay. Thank you. Thank you.
You're welcome. Yeah, it's an interesting question, interesting problem, interesting fruit.
Since like low doses of ethylene, 10 ppm, even you told that, so that's worked well in case of Manohari. So in our findings or in our opinion, even the 10 ppm, even that cannot enhance the, or you can say, initiate the ripening very quickly. So these are some of the points we have to ponder on.
Yeah, I think so. Yeah, it's some mysteries.
ADP less than 80 ppm, it doesn't work in our case.
For ethylene.
Okay, thanks, Dr. Badre, for your nice, full talk on the storage of the difficult mango. And if you have anything, we will be back on your email ID. Thank you. Oh, wait. Hello?
Still here.
Yeah, please.
Randy, thank you for the wonderful presentation. And I must tell the audience, It's 2:30 a.m. in the night in US and agreed to deliver the talk. So big thank you.
You're very welcome.
Thank you, Randy. And we look forward to your visit to India.
Okay. Yep. I'll stop by.
Thank you. Thank you so much. And I hope you had a nice interaction with my Italian speaker.
Thanks.
Okay, next we have Dr. Shalini. Dr. Shalini is a distinguished food scientist currently serving as scientist at Division of Food Science and Post-Harvest Technology, ICAR. She holds a PhD in food technology and has 15 years of experience in teaching research in food science and post-harvest technology. Dr. Shalini research expertise includes thermal processing, food quality, kinetics, enzymes, inactivation, and shelf-life extension, with a strong focus on millets and functional food development since 2014. Dr. Shalini is having H index of 28 with over 2,300 citations and has successfully guided multiple MSc and PhD students. Dr. Shalini has been actively involved in several extremely funded projects like DBT, DST, ICAR, focusing on nutrition, security, functional foods, and farmer empowerment. Her contribution have been recognized through several awards, including the Young Scientist and the Best Feature Article Award, along with multiple Best Poster recognition. Let's welcome Dr. Shalini, please.
Thank you so much for such a generous introduction. But at Amity, I gently feel at home. When I came to Delhi, this was the first place I worked in. So I have a very special affection for Amity. And again, I congratulate AIHSR to be successfully, and every time you're touching a new mark in the level of international conferences that ma'am is holding, and her entire team for putting it up all together. So congratulations, ma'am. So going on to the theme which I have been, which is there, that is the waste utilization, value addition, post-harvest management. Thank you so much. So before I actually move on to the real topic for which I have prepared the presentation, we have worked on the value addition of waste, horticultural waste particularly, and I'll be, of course, I'll be focusing on extraction of carbon quantum dots from the horticultural waste, which will be a sustainable approach for post-harvest management. I would also like to focus on the value addition of horticultural waste into various food products. I, being a food technologist and working in the area of horticulture under Dr. Ram Asre's leadership. So basically, we are the second largest producer of fruits and vegetables. We have reached 367.72 million tons production of fruits and vegetables recently. And however, we are also wasting a considerable amount, that is ranging from 15 to 28% according to different estimates. And in this ensuing global development, just yesterday, day before yesterday, Honorable Minister of Agriculture, he was saying that, like, we have to be self-reliant in India's food security. We cannot depend, food and energy, of course, now everybody understands. So we cannot depend on any other country for feeding our nation. And when we are talking of that, definitely we need to reduce the losses. We need to curtail the amount of losses which is happening on and off the field, even in the farms, from farms to the markets, and even in our own homes. As you can see that we are almost wasting 50 kg per person of fruits and vegetables and food per capita. Like that's a huge value which needs to be curtailed down. So I beckon everyone amongst all the audience that try to reduce the amount of wastage in food at your own personal levels. So horticultural waste, definitely we can convert into high value bioactive products. That is, we can have peels from the fruits, we can have the the pomace after juice extraction, we can have the seeds, the cores, the rind, the stems, leaves. We have been one of the students I congratulate you on developing the papaya seed cookies which have been served to us. So yes, there's a tremendous amount of work which is going on in this area, and we can actually go in for recovery of various bioactive compounds like polyphenols, flavonoids, which have antioxidant and anti-inflammatory activity, and that they sell like each and every compound. If it is in good potency, it can sell for even thousands of rupees, and that's required for cancer and chemotherapy adjuvants. So natural colorants and can be derived from the fruit peels, pomace. Essential oils can be recovered from the seeds and the rinds, and of course the dietary fiber is also very important, which can be put to use. Apart from that, we can convert them into nanomaterials like carbon quantum dots for advanced packaging materials and smart packaging. We can convert them into enzymes, biofuels, organic acids, and Dr. Ansari works on this area. So I was so elated to know of this, that somebody is sharing the same wavelength. Apart from that, in our own lab, we have worked on the value addition of waste products into horticultural waste into value-added products like pea pod powder utilization has been done in mayonnaise, because pea pod powder is rich source of protein. It is rich in sugars and of course fiber, and that helped to actually enhance the thermal stability of the mayonnaise and helped in the proteins helped in the emulsification of the fats in the mayonnaise, and the mayonnaise came out to be not only tastier and better in appearance, but also more stable, more thermally stable. We use the pea pod powder in buckwheat bread also, because the pea pod powder absorbs more water. So more the water is there, the state of the retrogradation and the scaling rate, related changes are slower. And we did developed instant soup powders also. Um, we are also working on the modification of starch from the field pea protein isolates. They are being consumed across the gyms in the country, and however the starch which is remaining, that can be converted into various value-added products, and the modification of starches is being used for other purposes. We have used bitter gourd pericarp from the overripe bitter gourd for development of oleogels. Coming on to the main topic, that is the utilization of the horticultural waste for green synthesis of carbon quantum dots. That can be a valuable high value commodity which can be developed. So basically what carbon quantum dots are, that they are very fine, less than 10 nanometers nanostructures, and they have a tunable fluorescence. That is, the fluorescence can be actually engineered and modified depending on the requirement. So they are having the biocompatibility. The optical properties are thank you. The optical properties, they are for these carbon quantum dots, they are coming from the fluorescent nature of these CQDs, and the safety of the carbon is also there. So without going for the like, it's subverting the like the toxicity problems which are associated with nanomaterials. They are much more safer, and they can offer numerous opportunities in terms of food preservation and enhancing the stability of various food products, as I will tell you later on. They can be used for intelligent edible coatings for subtropical foods. So how they can be prepared? There are various approaches to prepare them. You have a top-down approach, that is just like erosion. We are using various agents to actually shed off some certain layers and prepare the carbon quantum dots. or we can go from bottom up approach, that is we go for hydrothermal processing method, microwave pyrolysis, etc., and then generate the carbon quantum dots. So this is the way we are using in our lab. We are using, we are powdering the seeds and the pomace. We are going for hydrothermal pyrolysis and then dialyzing it, and then we are getting the carbon quantum dots. We are using various techniques to characterize them, like XRD for crystallinity, the UV barrier properties, fluorescence monitoring is of course there, transmission electron microscopy, and FTIR. The various attributes for the carbon quantum dots are that they are very stable. Toxicity problem is not much there. They are chemically inert, and of course, because they have carbon, it is biocompatible and it is tailorable. That is the best part about it, and water soluble. The applications are immense. They have been very highly used in sensors, in optical bioimaging, and other applications across many fields. So we are having dye sensitized solar cells. They're used in environmental protection, cosmetics and dye industries, chemical industries, across various fields. So once we prepare carbon quantum dots from horticultural waste, they can find immense applications across many sectors. So how do we use these carbon quantum dots in alleviating the post-harvest losses? The reason is that they exhibit antimicrobial activity, and then certain findings have shown that they can reduce the infection rate by even 146%. They have antioxidant activity, so it helps retain the vitamins, pigments, and bioactive compounds in the fruits and vegetables. It shields, as sir was saying, that you like how to protect the fruits and vegetables from the light. So even in the retail sections, we see that fruits and juices, etc., they are kept on the and under light, and then the photodegradative changes are taking place. So CQDs, they can absorb the harmful UV radiation and slow down the degradation of the light sensitive compounds. They extend the shelf life, of course, because of the virtue of so many activities, as I've told you earlier, and they are of course biocompatible and safe. So this is one finding recently by Zhu et al. Our findings are not yet published, but we are hoping to publish soon, and then I'll be sharing my own findings very soon, probably in the next seminar. So Zhu et al, they have used carbon quantum dots, and which have been prepared from ultrasound technology, and they have used sericin proteins. So sericin protein along with carbon quantum dots, they have prepared. They have coated on the fresh cut spinach, and that led to better quality retention in the spinach. As you can see that they have the antibacterial property against Bacillus subtilis by 146%. Against E. coli, it was enhanced by 157% compared to only sericin protein when carbon quantum dots were there. So what exactly happened? What exactly the findings were that the colony expansion was also delayed, not just generation but also the expansion. The flavor quality was retained better, and you can see in the leafy vegetables, of course, the physiological loss in weight is very important, and that weight loss was reduced by 40%, and malonaldehyde concentration was also decreased by 42%. As you can see the various graphs, I'll be leaving the presentation for the students to actually see and delve into the papers on their own. These are the pictures of the spinach, which were given the various treatments. This is only water treated spinach. This is the sericin protein. This is sericin along with the carbon quantum dots at 0.4%, and this is 1%. And you can see the retention of the spinach quality on the up till the 8th day also. So we can also integrate these carbon quantum dots into smart packaging films, because this is digital agriculture that we are talking of. So when we are having digital agriculture, definitely we need some sensors in the packaging material which can tell us that, okay, this is the status of the fruit or vegetable inside it. So these various target molecules like ethylene or oxygen or CO2, they can interact with the carbon quantum dots and lead to the changes in their fluorescence spectra and or the intensity, and then we can measure it and enable us to determine the real-time fruit quality inside the package or the storage house. It can be used for ethylene detection, oxygen and carbon dioxide monitoring, and even heavy metal contamination in the wash water or package environments, owing to various tunable properties and also engineering of these carbon quantum dots by doping them with certain metals. There is another very interesting study by Park et al. That is high energy blue light radiation, how it was blocked. So this is one study in which the reactive oxygen species generation was blocked because of the presence of carbon quantum dots, and this finding was very interesting, and the quality of the films was also better. Better transparency, better brightness, and along with that you have a UV shielding effect. Similar work has been done on the antimicrobial activity, that is the carbon quantum dots generated from quinoa roots, and they have antimicrobial activity against Staphylococcus aureus, E. coli, and Candida albicans. In juices, the carbon quantum dots, they were added and in the packaging material, and they were able to retain the yellowness index and carotenoid content of the orange juices as well as in the grape juices, and the protective effect was similar to ascorbic acid addition. So this is a very important finding in terms of retail juices and other colored commodities. So I would like to conclude my talk by saying that not only waste valorization, we are reducing the amount of the quantum of waste which is generated and going into the landfills. We can, of course, valorize them into various products like anthocyanins, carotenoids, polyphenols, and the newest addition would be carbon quantum dots. These have antioxidant and antimicrobial actions, not only for packaging but also for health applications. They have their applications in smart packaging, and therefore we can transform these low value residues into high value nanomaterials with multifunctional properties across various sectors, and together all these strategies put together can close the loop in the horticultural processing, and we can have a circular economy approach towards the horticultural food processing, turning the waste into innovation. So at the end, I would like to say that in the cycle of nature, what we call waste is but an untapped promise which can be transformed into guardians of freshness, and that is restoring the post-harvest, the freshness of the fruits and vegetables. And these derivatives remind us that preservation is not the resistance to time, but we can harmonize with it. Thank you so very much for your patience listening, and I'm sure the youngsters and their guides alike will take home this message and put their energies into this fora also. Thank you so much.
Thank you, Dr. Shalini, for your nice and informative talk. Okay. The session is open for queries. If you have any queries, see, actually, yeah, please, 1 minute. Actually, she was talking about carbon quantum dots. So first of all, we should understand what these quantum dots are all about, okay? And what are the various applications in today's era where we can use it in real life applications. You know, quantum dot means the particle size is almost in the range of Bohr's radius. Just think of what is Bohr's radius, atomic scale. And the advantage is that with quantum dot, you are having a very wide surface area. Okay. So that is basically the principle. We are having a very wide surface area. Since the size of the particle becomes very, very small, the surface area increases. And if you are having a very wide surface area, you can enhance the properties as well. Now, yeah, ma'am, please, queries. Can anybody can give him a mic, please? Ma'am, up.
I'm Dr. Niveta, and Shalini is my colleague. We work in the same building, no different departments. It was a nice talk to listen to, Shalini. And my query is like carbon quantum dot. It's a emerging area nowadays. A lot of work is being done in this area. My query is like earlier we were using a lot of preservatives, and later on it came to the light of people that there are a lot of health issues related to preservation. So what are the implications if we are using these carbon dots in the juices or edible things for preservation, considering that their size is very small and they can even cross the blood barrier? So how their impact will be there on the health issues later on? Is there any such kind of studies reported?
Yes, ma'am. Thank you so much. That we are going for clean label products now, and we want chemical free products. So what I was talking about integration of carbon quantum dots into the packaging material, ma'am. And of course, in edible coatings also we are adding. Because they are derived from carbon, and after chemical hydrolysis, the studies so far have demonstrated no adverse effect on the health. However, more studies are going to come about in the future. But as of now, so far, no adverse effect has been observed.
Are there any guidelines, regulatory guidelines regarding the use of the carbon?
Yes, ma'am.
Quantum dot.
In EU and US, it has been approved for use.
It has been approved with certain caveats or as it is?
Ma'am, to the best of my knowledge, there are no caveats as such. They have been approved for use in intelligent packaging films. And
only in packaging, not in food.
Not directly in as edible coatings yet.
Yes.
But for intelligent packaging, yes, they have been approved
packaging
across
only.
US and UK.
For only packaging, because it's not being consumed by the consumer directly. Okay, thank you.
Okay, and add on to Dr. Shalini. Actually, if you are talking about quantum dots, so we can basically prepare it from lemon juice, orange peel, orange extracts. So these are all natural. And if you are talking about lemon drink, of course, there are some content of quantum dots is also there. So it's damn safe if you are using, because none of the chemicals are involved. And it is having a very high impact values, and it basically enhances the properties of the material whatsoever you are using. So quantum dot has definitely having a very evident role in all these applications. Any queries from the student side? Yeah, please. Yeah. See, ma'am, there is a difference. Please. See, actually, one thing is the size. The size can be 2 nanometer, 3 nanometer, 10 nanometer. Up till 10 nanometer, it is quantum dot. And then the second thing is the morphology. The morphology means the shape, the size, the structure, that changes. And if that changes, the band gap also changes. So that means it will show you blue emission when it is exposed with a UV light. The same material can show you red emission, it can show you green emission depending upon the size. So that means these are the vectors that is varying, and the important is the band gap, because ultimately we are to tune the band gap. If you are able to tune the band gap, actually what happens? See, in all the materials we are having electrons, and important thing is that we have to excite that electron. So as smaller the size of the material is, as it is easy to excite the electrons, because all the electrons are there on the surface. Yeah. You are asking something? Yeah, please. Of course. Be there in my talk. I will I will be talking about all the details, how we can prepare quantum dots and what are the various applications of the quantum dots. See, if you're talking about peels or any other materials, see what there is no cost. First thing is this. Second thing is that you can use from the waste product. Suppose हम चाय पीते हैं या कॉफी पीते हैं, हम थ्रो कर देते हैं. Okay, like this kind of bottle we are having, it's of PET. Okay, तो ये टूट गया, इसको भी यूज करके we can basically prepare quantum dot from all these materials. एलोवेरा जेल आपके पास में है, नीम की पत्ती होती है, नीम leaves are there. So you can prepare quantum dot from any material. No chemicals is involved, so there is no toxic effect. And the preparation route is very, very simple. You can prepare here itself in the lab, in the university within one day. Okay. Any queries from anybody else? Yeah, ma'am, please. Ma'am, see, if you are talking about yield, it's very, very low because actually we are using the supernatant, and supernatant is having the size of the atoms. And if you're talking of a material which is having a size of the atoms, that means you are simply not going to have a very high yield. But ultimately, you can have the powder form that I will be talking in my paper. Be there. That will be an interesting talk. Okay. So if there are no more queries, let's switch over to the next speaker. Can we connect to Professor Colley is here? Yeah, Professor Colley, can you hear us?
Yeah, very well.
Thanks, sir. Okay, Professor Colley, he is basically associated with Department of Agriculture, Food, Natural Resources and Engineering University at Italy. He is a distinguished full professor of post-harvest technology at the Department of Agriculture Science, Food, Natural Resources, Engineering of University at Italy. With an extensive career dedicated to horticulture science, he has held significant leadership positions that influence the global agriculture landscape. Most notably, he serves as the chair of division of post-harvest and quality management for the International Society of Horticulture Sciences. Dr. Colley's research and development portfolio is defined by a focus on the intersection of technology and produce quality. His primary interests include the equipment implications for the quality of whole and fresh cut fruits and vegetables, ensuring the industrial processing maintains the integrity of the product. As a globally recognized authority in post-harvest science, Dr. Colley is frequently invited as speaker at the field's most prestigious conference and symposium. His commitment to international academic exchange is reflected in his role as a lecturer of more than 30 distinguished institutions across the globe. Dr. Colley's work is evidenced by a robust publication record and high citation metrics. He is the author of 170 plus index scientific articles, contributing significantly to the foundational and applied knowledge of post-harvest technology. According to Scopus, his work has garnered 3500 citations, resulting in an index of more than 34. These metrics underscore his position as a highly influential figure. Now let's welcome Professor Colley. Professor, can you share your presentation, please?
Yes, I will. Okay. Can you see it?
Yeah. Just make a full screen. Yeah. Now you can start, please.
Okay. Let's see if I am able to remove this stuff from here. Okay. Good morning. I'm very happy to be in this important event. Thanks, the organizer, for inviting me. I will try to keep my presentation into the 10 minutes which were allocated for me, and trying to present some of the results we had in the last few years on quality preservation during storage for pomegranate fruit. I want to introduce just saying that pomegranate fruit is long been established as a crop in Italy, although it's never been a commercial crop. In the last 20 years, it became a commercial crop. And just to give you an idea, in 2012, there were only 20 hectares commercially established as a commercial orchard. Now we have more than 2,000 hectares. So there's been a rapid growth. Most of the pomegranates produced in Italy is wonderful variety. I think about 80% of it. And the crop is characterized by a pretty narrow harvesting season. Usually it starts in September with the earlier varieties, but most of the fruit is harvested late October when wonderful ripen in Italian conditions. And most of the cultivation is concentrated in Puglia and Sicily regions. So there is a need of longer post-harvest life in order to commercialize all the product which is harvested. Usually, most of the crop is marketed by Christmas with like 4 to 6, about 8 weeks of storage in normal refrigeration, although quality at the end of this storage condition is not the best one. So we need to extend post-harvest life in order to have more income for the producers, and that was the focus of our work at the University of Foggia, together with other institutions, and in a very important cooperation with the industry. Just a little bit of background on pomegranate fruit, which is known to be a non-climateric fruit. It is characterized by a low respiration rate, which usually declines during storage. Ethylene production rate is less than 0.1 microliter per kilogram per hour at 20 degrees C, so it's not a very important ethylene producer. Respiration rates, of course, increase with temperature, and the Q10 value is estimated about 2, so that means that temperature makes a difference in terms of metabolic activity of the product. Main causes of post-harvest losses in pomegranate, the development of molds and rots. It's one of the things which limit the post-harvest life, and most of the attacks start from the crown, where the flower residues are there, and especially if wet during the post-harvest handling, it's very likely that if fungicides are not applied, it's very likely that molds and rots will start from there. It's very important to prevent mechanical damage, especially during harvesting and during post-harvest handling, because again, most of the post-harvest molds and rot development start from pre-existing injury. Weight loss, it's another problem. Pomegranate is very sensitive to transpiration and consequent dehydration. Physiological alteration due to wrong temperature management during storage. Also, this is one of the problems associated with long storage with pomegranate. And aging and senescence due to respiration, loss of tissue integrity, and consequence oxidation, which starts a number of which is at the basis of a number of physiological alterations. The atmosphere modification, it's been demonstrated to be very important in terms of slowing down development of molds and the decay in fruits. This is an experience we did a few years ago, where we treated pomegranate with the low oxygen and high carbon dioxide. Mainly, high carbon dioxide is very important in terms of fungistatic activity. And especially when you get into very long storage condition. In this case, you can see the fruit after more than 4 months at 8 degrees C, which is a non-chilling safe temperature. And even after 140 days, fruit looked pretty well, although some decay, started to interest a good amount of the fruit. So let's say that fruit can be kept at least for 3 to 4 months in a controlled atmosphere with the low incidence of molds and decay, even at non-chilling temperature like 8 degrees C. This also can be obtained in modified atmosphere packaging. This is an example of about 3-month storage at 6 degrees of wonderful pomegranate with in-bin modified atmosphere packaging. Here you can see, this is the air control. And here you can see some problematic application of in-bin modified atmosphere packaging. This is a case of a broken bag, and you can see some mold development and the problem associated with the not a good buildup of atmosphere. And this is defective seal. In this case, you can see that there is a very huge mold development, because defective seal means that you don't have a consistent atmosphere modification, but you still have a lot of water condensation within the bag. While if you have a good satisfactory map conditions, you can still have water condensation, but you don't have the development of mold. So atmosphere modification is very important in terms of mold development, both in packaging conditions and in CA storage conditions. Another limitation for long storage is due to some physiological alteration. One very important is associated with low temperature storage. Chilling injury is developing in fruit stored below 4 to 6 degrees Celsius, especially after 4 to 6 weeks of storage. And chilling injury is associated with some rind browning, rind pitting, but mostly the problem is associated with internal symptoms, which goes into some yellowing of the mesocarp and darkening of the arils, which will rapidly become non-marketable. Another alteration, which is frequently associated with temperature, is the development of ask scald. Ask scald is more associated with higher temperature, and looks like it's stimulated by some dehydration of the rind. So water loss is very important from this point of view. The main difference is related in terms of symptoms is related to the fact that ask scald is mostly an external defect, so why it doesn't show any problems in terms of internal defect. There is some publication we recently did on both these alterations that you can look at it. Atmosphere modification also works very well in preventing the development of chilling injury. This is some application at 4 degrees, which is supposed to be a chilling temperature, especially after 4 to 6 weeks. And in this case, you can see that up to 140 days, the amount of chilled fruit was very low. This you see after 4 months, and this is after 140 days. So you can see a very strong effect of atmosphere modification in terms of development of chilling injury. Also, atmospheric modification is very effective in slowing down husk cold. This is some data which are not yet published, but I hope they will be published in the next few weeks, where you can see that, whenever you have atmospheric modification, in this case it's low oxygen or low oxygen with high carbon dioxide, you can keep the fruit with very, very little incidence of husk cold while in the control, especially in this case, storage temperature was 11 degrees. So we stored at 11 degrees in order to favor the development of husk cold. So atmosphere modification is very important also from this point of view. Another strategy to reduce the development of chilling injury is the use of some elicitors, which have been demonstrated in many studies to have an effect. In this case, we applied methyl hasmonate, salicylic acid, oxalic acid, and putrescine. We stored for 120 days at a chilling temperature, like 2 degrees, plus 3 days at 20 in order to show, to better show chilling symptoms. And also we had the same treatment with fruit kept at 8 degrees at non-chilling temperature. And what we could see is that, at transfer after chilling, we could see a very strong effect of oxalate. And after 120 days at transfer, we didn't have any chilling injury showing from the fruit. And after 3 days at room temperature, even after 120 days of storage, the effect of oxalate was very strong compared to all the other treatments, including other elicitors like methyl jasmonate or salicylic acid. So we tried on a larger experiment at the industry scale to treat fruit with oxalic acid for 40 days plus 3 days at 20 degrees and 95 days plus 3 days at 20 degrees. And also we compare this treatment with the same conditions, but applying in-bin modified atmosphere storage. Well, actually, the conditions we had were kind of extreme because oxygen went below 1% in both after 40 days and after 95 days. And carbon dioxide went more than higher than 20%. But still, when we had the combination of MAP and oxalate treatment, the chilling injury symptoms was much lower than that, lower than the other fruit. And also you can see here from electrolyte storage also that the best conditions were always the one related to the combination of modified atmosphere packaging and oxalic acid treatment. Another application that I want to show is an ongoing experiment actually, where we try to simulate cold quarantine treatment on fruit destined to export. We applied the cold quarantine protocol, which is approved by USDA, and it also approved by China for exporting fruits from areas where Mediterranean or tropical fruit fly are present. And in particular, the quarantine protocol include exposure of the fruit at 1.67 degrees C for 16 days. So we applied this protocol to pomegranate fruit in air and in controlled atmosphere with the same gas formulation. in order to see if this could prevent the development of chilling injury for such a long time. And if with atmospheric modification, this quarantine treatment could be integrated during the shipment and the value chain of pomegranate fruit. So in order to do this, to explore this possibility, we actually started from fruit which had already a post-harvest history. So fruit were stored, were already been stored for 6 weeks at 6.5 when we started the experiment. And we compared different conditions. So one condition was expose the fruit, which I say they were already been stored for about 6 weeks. So the treatment compared was continuous exposure at 6.5 in air for additional 40 days. Applying a cold quarantine simulation with storage at 1.7 in air for 17 days plus an additional 23 days at 6.5, so just changing the temperature. Another treatment was to expose the fruit in a cold quarantine protocol for 17 days, but in controlled atmospheric conditions, and then transfer at 6.5, maintaining the controlled atmospheric conditions. And the last treatment we applied was a cold quarantine simulation in CA condition followed by air at 6.5. I just will show the appearance of the fluid. So this is the cold quarantine applied in air. This is the cold quarantine applied in CA at transfer. And you can tell there is a slight difference in terms of appearance, in terms of this fluid started to show external and internal symptoms. But after the additional 23 days in storage, so total of 40 days after the treatment, you can see a very large difference in terms of development in chilling injury when the fluid were quarantined in air compared with the fluid which were quarantined in controlled atmosphere and then held in controlled atmosphere for additional 20 days. Future perspectives, especially when we are considering long storage for pomegranate fruit. Most of post-harvest problems, including as cold, are due to oxidative stress triggered by dehydration, high temperature, and time. And from this point of view, reducing temperature is important, but we cannot go much below 8 degrees if we don't do any additional treatment. Chemical like oxalic acid and or physical treatment like reducing water loss or atmospheric modification appears to be very effective in limiting the development of many post-harvest related problems. Atmosphere modification, either through controlled atmosphere or modified atmosphere packaging, also appears to be very effective in reducing decay incidence, especially at higher storage temperature. And at least in Italian conditions, CA rooms equipped with high relative humidity and high carbon dioxide conditions appears to be best option for long storage of pomegranate fruit. And these allow to be present in the market in the month just after Christmas, where the availability of good quality pomegranate fruit is very, very low. I thank you for the attention, and also I thank some of the companies both in Italy and in Peru, which helped us, supported us for these trials. And this is the Facebook page we have at University of Foggia for our where we show our results. If there are any questions, available, of course. Thanks very much for your attention.
Thanks, Professor, for your nice and wonderful talk. Let's give him a big round of applause. Yeah, now the session is open for queries. If anybody is having, please, from the audience. Yeah, we have one.
Okay.
Your talk was very interesting, and on such a valuable crop like pomegranate, going for the reducing the chilling injury along with the use of carbon like controlled atmosphere packaging. That has a lot of economic implications. But sir, how would we maintain these? Can we maintain these controlled atmosphere in the reefer packages which were meant for export? Will it be possible?
Well, actually, most of exporting of, especially exporting from South America to Europe or Asia, especially, I mean, most of those cold quarantine treatment application we did for exporting to China, actually. Anyway, most of the exporting take place in modified atmosphere packaging bags, which are commercially available from many different companies. So fruits are packaged in bags and which are actually liners in carton boxes or plastic crates, and they are shipped in these conditions. Usually, atmosphere modification is very effective in this bag.
Okay, thanks, Professor. So, yeah, sure. We have one more question.
Yeah, please.
Thanks. A very practical lecture. And may I know what's the status of pomegranate aril marketing in your minimally processed pomegranate aril marketing in your country, especially with reference to Italy? What's the now status, mean dimension, how much you people are doing commercial?
Yeah, there is some marketing of ready-to-eat arils in Italy, and as I said, pomegranate industry as a commercial industry is young in Italy, although is becoming very large, and the availability of ready-to-use arils is very important in terms of marketing of this commodity. And one of the problems associated with the consistent ready-to-eat arils industry is related to the availability of good quality raw material throughout the year. Because as I said, most of the harvest is concentrated in 2 weeks. And the season in normal conditions is very short, it's about 2 months. So in order to have, to conquer consumers, you have to have the availability of ready-to-use arils for much longer season. And the trials I showed with controlled atmosphere for 140 days application was dedicated to the quality of arils after the long storage of the whole fruit. So after each sampling time, we also tried modified atmosphere packaging of fresh arils obtained by the fruit stored for 140 days to see if there was any difference in terms of quality of the ready-to-use arils. And of course, there was a difference, but still storing all fruit for 3, 4, even 5 months in controlled atmosphere still allows some acceptable quality ready-to-use arils to be stored at least for 7 to 10 days in modified atmosphere packaging. And this is the maximum you can do with pomegranate grown in the country. Then after May, you have to use imported fruit from the other hemisphere.
Thank you, Professor Coily. Thank you.
You're welcome.
Thanks, Professor, once again. Now we are moving over to the next session. This is for oral presentation evaluation, theme 3, post-harvest management, value addition and zero waste horticulture. So there is a limitation of time. We are giving 3 minutes for candidates, starting with Vrinda Sharma. Let's have her presentation.
Thank you, sir. My name is Vrinda Sharma. I am PhD scholar from Sharda University, first year student under the supervision of Dr. Sujata Pandit Sharma, Associate Professor, Department of Food Science and Technology. I am going to present my review on comparative study of potential use of bougainvillea as useful compound. First, go through with the introductory part. The genus was first identified in 1768 by Luis Antoni de Bougainvillea during exploration in Brazil. Bougainvillea is a flowering plant which is a genus of Nittegenacea family that is native to South America, and it is widely cultivated in semi-arid region for the purpose of ornamental, horticulture, pharmaceutical, and so on. Bougainvillea spectabilis is a native of Brazil that is characterized by dark green, hairy leaves and bright red or purple bracts and its application. The plant is cultivated globally, including India, Brazil, USA, China, Thailand, and Australia. So this is a brief description of Bougainvillea spectabilis. These are some varieties of Bougainvillea. First is Bougainvillea glabra, that is red, and Bougainvillea spectabilis, that is pink, and Bougainvillea beautiana, that is white. The objective of this review is to identify the different types of bracts, spectabilis, glabra, and beautiana. You can see in the pictorial representation in my slide. And second, comparative analysis of various bracts for bioactive compounds, identification, and its use. There are several status at national levels. For example, in first authors, Shivani et al. Study the extraction of natural dye from Bougainvillea glabra. Second, they highlight the phytochemical richness and antibacterial properties of Bougainvillea glabra. And third, focused on food application, particularly the development of functional beverage using Bougainvillea flower powder. So this is the national level work. Next status at international level, there are various researchers have done several discovery related to Bougainvillea glabra, beautiana, and spectabilis. There are several research gaps. For example, most study focus mainly on Bougainvillea spectabilis. That means only one variety is chosen. There's lots of varieties left like glabra and beautiana. Comparative study on various Bougainvillea varieties under standardized condition, but still there is a lack of sufficient data regarding the nutritional composition and bioactive profiles across these varieties. Next, move on to the material methods. For example, Bougainvillea beautiana. This is the first variety, and second is Bougainvillea spectabilis. These are some methods how I make the powder of Bougainvillea spectabilis. These are some research taken from other research papers, phytochemical parameters, and the most important thing is that application in food industry. For example, natural food colorants, preservatives, functional food, herbal tea beverages, potential use in meat products, and alternative to synthetic additives. So this is the picture taken from other research paper. This is a proof that Bougainvillea spectabilis is edible. For example, Bougainvillea fritters and salad. The people are consumed in Thailand in the form of fritters and salad. But India, nobody is enough aware about this variety. So the focus of this my study is to make the people aware about this variety, and we will consume it. Let me conclude my presentation. Bougainvillea spectabilis glabra and beautiana, rich in bioactive compound. This is the objective. That's why we chosen this flower. Why not I choose other flowers like marigold and sunflower, which includes phenolics, flavonoids, and betalain, because they show antioxidant and functional ability, along with emerging in food and nutraceutical application. These are some reference the other people's work done on spectabilis, glabra, and beautiana. And in food application, there is a left huge gap in this. I would like to thank my supervisor, Dr. Sujata Pandit Sharma, for her constant guidance, valuable suggestion, and encouragement during my research work. Her support and motivation have played a significant role in helping me carry this research forward successfully. Thank you.
Thank you, Vrinda. Now we have online presentations, and first I call upon Mr. Jose Raju.
Hello, hello, ma'am. Hello, ma'am. Can you hear me?
Yes, I can hear you. Can you open your camera?
Yes, ma'am.
Can you share your presentation?
Yes, ma'am.
Okay, before that, you have got 3 minutes to present your presentation. So kindly wind up sooner. You can go on.
Okay, ma'am. One second, ma'am.
Your time has already started, okay?
No, ma'am, I have some need to. No, my has.
Invite someone else if you're not ready.
Ma'am, can you see my slide?
No, we cannot able to see your slide.
Share your slides.
Just cut down the time for. ये इनको और दूसरे सेशन में शिफ्ट कर दो इनको दूसरे जूम सेशन में हो दूसरे सेशन में हाँ
Jose,
Yes, ma'am.
you present your presentation later. Now I'll call upon Dr. Sajil Ahmed.
Okay. Okay.
Dr. Sajil, Division of Food Science and Post-Harvest Technology, ICRAHOR, New Delhi.
Good afternoon, ma'am.
You can present.
Ma'am, slides are visible.
Sajil, you can start. You have got 3 minutes.
Ma'am, slides are visible?
Slides are visible, yes. Your voice is a bit low. But yeah, slides are visible.
Good afternoon, respected panelists. My oral presentation topic on post-harvest application of the 24 epibresnolite, a strategy to improve the nutritional quality and storability of cherry tomatoes. As we know that India is the second largest producer of the horticultural crop, that is 369.05 million ton, but we lost 10 to 15% due to the improper post-harvest handling. So in every morning when we saw the newspaper that enhancing the shelf life with the unhealthy practices like we left with the artificial green colors, that traces of the pesticides, and these are so forth. So these are the major research gap on the basis of we have decided our research objectives. These are the research gap: environmental and health risks, synthetic fungicide dependency, chemical residue concern, and regulatory limitations. So the post-harvest problem in the cherry tomato, that chilling injury, wilting, shriveling losses, highly perishable and nature, and limited shelf life. So on the basis of this research gap, we have worked on the exogenous application of Sprite for shelf-life extension of the cherry tomato. So it is how to work Sprite. So it activates the antioxidant defense system by scavenging the ROS activity. It increases the phytonutrient accumulation in the fruit, and it increases the fruit firmness by regulating the cell wall softening. So this is the overall my research graphical representation of my research work. We have dipped the cherry tomato with different concentration of the Sprite, then stored under the cold storage condition, 10 plus minus 1 degree centigrade, 85 to 90% relative humidity. And we have analyzed for their physical, physicochemical, and enzymatic activity. The result revealed that ascorbic acid content, total antioxidant activity, total phenol content, and total flavonoid content that were retained higher when the cherry tomato fruit treated with the epibresnolite treatment. And this is the picturesque effect of the Sprite on the cherry tomato. In the control fruit, they lost their nutritional value and consumer acceptance after 15 days of the storage, while the Sprite treated fruit, it showed that the Sprite 5 micromole, it retains the higher firmness, higher bioactive compound, higher antioxidant, and higher phenolic content. The conclusion of my research study: cherry tomato fruit treated with 5 micromole per liter, that enhanced the shelf life of the cherry tomato around 35 days, that is 15 days extra compared to the control fruit. Epibresnolite suppressed the respiration rate, ethylene evolution rate, and it also retained the higher firmness bioactive compound. Sprite, it nearly doubled the shelf life of the cherry tomato compared to the control fruits. The future research should investigate the trait-specific transcriptomics and genomic analysis. So I am working on these aspects. I have published these two research papers in this area. Thank you everyone.
Thank you, Sajil.
Thank you.
Now we have one more, Aarti Dilip Dongare.
Good afternoon. Am I audible and is my screen visible?
You are audible, but you are not sharing your screen.
Okay, just a second. Is it visible, ma'am?
Yes, it's visible. Aarti, I would like to inform you, you have got 3 minutes.
Yes,
so
ma'am.
It up within 3 minutes.
Yeah. Good afternoon to everyone. I'm Aarti Dilip Dongre from MIT University from Pune. And my research topic, which I'm presenting today, is sustainable active packaging, agar-based films, which are being fabricated with green synthesized silver nanoparticles for dairy products. Mostly I'm focusing on cheese. So I'll just briefly introduce the introduction. So nowadays packaging has been a chemical based packaging which causes and several global pollution. So for this purpose we need an alternative which will be sustainable, edible and biodegradable packaging which can replace the conventional plastics. Then the if we come to nanotechnology, when we add silver nanoparticles in the packaging, which is formed by agar-based films, it can be act as active packaging with superior antimicrobial protection also. Secondly, green synthesis. This is a method in which no toxic substances or chemicals are being used, and we mostly focus on the plant extracts, which from which we can derive the nanoparticles. And in my research, I have been using banana peel as an nanoparticle extraction mode or source, we can say. Secondly, the objectives of my current study are, first of all, I would like to tell you like since synthesis of silver nanoparticles using green methods from banana peels. Secondly, these silver nanoparticles were enclosed or embedded in an edible films using biopolymers, and the films were further evaluated for antimicrobial activity, and this was being studied in the application of food packaging. With various literatures which I have been studying, I have found out this literature, the authors which have been finding the this thing findings, and from this findings, I have seen a research gap or a problem statement in this kind of research, that there is a limited use of banana peels for silver nanoparticle synthesis, and banana peel has been wasted or annually almost 10 to 12 million tons in India. So using banana peel as a biomass for extraction of nanoparticles is very essential. Secondly, there has been a lack of optimized film formations and study on real food applications. And further, there should be a need for this thing, food safety also. So developing an, yes ma'am?
Please come to result slide. It's
Okay.
already 2.5 minutes over.
Yeah, ma'am. Yeah. Yes. So this was process which I have been used. And the main findings from this research topic are synthesis of silver nanoparticles, film development, and which was antimicrobial, and it was mostly used. This is the soil biodegradation, day 1 and day 9. And this is the microbial resistance profile. So finally, I would like to conclude that you can use this thing as a sustainable synthesis of banana peel waste, and which has a high microbial agent. Also, you can enhance the properties of this film by using different plasticizers, which will provide you strength. It has a wide microbial antimicrobial activity also, which is used against E. coli, Staphylococcus aureus, and Aspergillus, and it can extend the shelf life of cheese up to 10 days, and it is 100% biodegradable. And the final statement I would like to conclude, this active packaging system successfully bridges the gap between the food safety and environmental sustainability. So these are the references which I have referred, and I would also like to mention the future aspects of my study, that we can transit the laboratory scale into commercial manufacturing of edible films. Again, you can control the particle size, shape, and concentration to enhance the antimicrobial efficiency. Thirdly, we can incorporate these films with antioxidants, probiotics, and essential oils, and create an active and intelligent packaging systems, and develop smart films for packaging of the food. And lastly, cost reduction and commercial viability, like agro waste or waste valorization, can be seen into this project. Thank you. Thank you for listening me patiently and giving me this opportunity. Thank you.
Thank you, Aarti.
Yes,
Now
ma'am.
we'll move on to our last presenter, Miss Neha Kumari. Sneha. No, she's coming. She's a. She's the last one. Okay, since Neha is not online, we'll be winding up the presentation session. Thanks to all present.
Sorry, can I ask you? I haven't present yet. I joined the link, but it is not working. This morning.
I'm sorry.
I supposed to present yesterday, but they move it today. I haven't present my presentation yet.
Sorry, this is another link. You have joined the wrong link. Go for the second link.
No one is there. I joined and no one is.
No, not this link. Sorry. Okay. So now I would like to call Ansari sir to kindly summarize, and then we'll move to felicitation.
Okay, so the session has been concluded. We have two keynote address, one with Professor Ram Asre, another invited talk from Dr. Shalini, and we have a keynote speaker too, Dr. Badre from Michigan State University, and invited talk two was from Professor Kolali. Apart from that, we have oral presentation by the students, and 3 students participated and they have presented their talk. And here we are concluding. That's all. Thank you.
Felicitation. I would like to request Nutan Kaushik madam to kindly felicitate our session chair, Dr. Jamilur R. Ansari sir. Sonia. Yes, ma'am.
So with this, we have concluded the session 3. So we will be moving towards the session 4. I request Sonia to kindly replace the. Okay. It is my privilege to welcome you all to session 4, Climate Resilient Horticulture, Urban and Backward Farming. This session focuses on one of the most pressing needs of our time, developing sustainable, climate resilient horticultural practices while promoting urban and backyard farming as the viable solutions for food and nutritional security. I also take this opportunity to invite the presence of my coordinator, Mr. Tushar, and our reporter, Dr. Ajay Tomar and Dr. Tarun Sarma, for their support in conducting this session. I will also like to acknowledge our distinguished speakers who have joined us from esteemed institutions across India and abroad, bringing with them valuable expertise and insights. I'm confident this session will provide meaningful discussion and innovative perspective on sustainable horticultural practices. I feel honored to extend a warm welcome to our esteemed session chair, Dr. Salini Gaur Rudra, Senior Scientist, ICAR, Indian Agricultural Research Institute, New Delhi. In former session, they have already announced the brief CV of MEM, but hereby I'm again announcing it is my privilege to So I now request our respected session chair, Dr. Salini Gaur-Rudra ma'am, to kindly address the gathering and introduce the keynote speakers. Please, ma'am.
Thank you so much, Devi. It's a privilege for me to be able to listen to the dignitaries and so many learned scientists in this gathering. So our session is on climate resilient horticulture, urban and backyard farming, and we are really privileged to have amongst us the keynote speakers, Dr. Umesh Thapar, postdoc from Italy, and sir is working in Bisdahan Chandra Krishi Vishwavidyalaya, West Bengal. We also have Dr. Nivita Jain. We have invited who's going to deliver the keynote address also. And Dr. Akuzena Gongales Coloma, ma'am, is also there. She's from Spain. Dr. Maria Andres from Spain. And followed by that, we'll have the oral presentations. I would like to introduce Dr. Umesh Thapa. Could you please grace the dais, please, sir? So Dr. Umesh Thapa is a distinguished professor in the Division of Vegetable Science in Bidhan Chandra Krishi Vishwavidyalaya, West Bengal, with over 3 decades of dedicated service since joining the university in 1993. Many of the students might have been born by them, but sir has been working in this field. He earned his PhD in horticulture from BCKV in 2000 and pursued postdoctoral research in hydroponics, soil-less technology at the University of Turin, Italy in 2009 under the prestigious New India Project Fellowship of the Government of Italy. His research expertise spans protected cultivation, hydroponic and soil-less culture systems, microgreens production, vegetable grafting, breeding of underutilized vegetables like winged bean, teasel gourd, garden pea, brinjal, seed production, and sustainable nutrient management. So, all encompassing everything, in fact. Dr. Thapa has significantly contributed to advancing high-tech horticulture and climate-resilient vegetable production technologies in eastern India. Sir has guided 26 masters and 13 doctoral students. He has authored or co-authored 24 books, numerous book chapters, practical manuals, and over 120 research papers in national and international journals. Dr. Thapa holds 2 design patents on automated hydroponic devices and urban gardening robots. Dr. Thapa has held several important administrative positions, including Director of Extension Education, Dean Students Welfare, Chairman of the Placement Cell, and currently, sir is Principal Investigator of the ACRIP on onion and garlic. He has successfully completed and is leading multiple industry-sponsored projects on biostimulants, nutrient management, and protected cultivation. Widely recognized for his contributions, Dr. Thapa has received several prestigious awards, including Lifetime Achievement Award 2023, Eminent Scientist Award, Eminent Professor Award, Bharat Jyoti Award, and Outstanding Scientist Award. Dr. Thapa is a life member of several professional societies and serves as reviewer and editorial board member for many reputed journals. He has delivered invited lectures and keynote addresses all over globe, almost in Italy, Netherlands, Malaysia, Sri Lanka, and Thailand. And we are really grateful to have your presence over here. And I'm sure the students are going to be enlightened by your words. So not barring between you and the students, kindly.
Okay, come on. Can you put them my PPT? Excuse me. Because I have to go for that session I was supposed to. देखो अमिथी 9th April. ये तो नहीं, ये खोज कर दीजिए तो मेरा नहीं आइए, ये नीचे से मैं चला जाऊँ, ये मेरा ठीक है। एंटर मारने का ना, एंटर मारने का ना मैं तो देखा, ख्याल से एंटर मारेगा, तब पंखा एंटर मारेगा, हाँ, ओके फॉरवर्ड, ओके, good morning to everybody. First of all, I would like to thank the organizing committee of this esteemed university who has invited me in this beautiful international seminar. Since I'm here from the yesterday onwards, and I would like to thank all esteemed member of this university who has given me this opportunity to interact the students of the great university of India, I can say in the present scenario, and as well as respected dignitaries present in the dais, as well as in front of the dais, and all other members, Kamal sir, ma'am Arpita ma'am, and everyone who are present, and the students who are present over here. Today I'm here to speak in the new subject, I can say as the present scenario, that is smart and the cost-effective soilless farming for high-value vegetables. And this is what I want to add as a new avenue for the urban entrepreneurship. So as my time has been allocated, the very 13 minutes, I have to complete as because I have to go for the one poster sessions also. So I will just highlighted the things in the very, very brief. First of all, I like to say why in this present scenario, we are talking about the hydroponic soilless farming and the new digital way of the farming stuff in our Indian scenario also. As all of you are know very well, the present scenario of our country is not so much like the previous time that our country has something more for the food productions and like that. No doubt, today morning only some of the our presenters of food in case of the food, we are fully sufficient. But if I talk about the vegetable sectors, in case of the vegetable production, still we are not in the full production, although the productions and the productivity of the vegetable sectors in our Indian scenario is also very much. That might be the reason we are in the second positions after China. But if we think about the recommendation doses of the vegetables per adult per day, which we have to consume, is not sufficient, because the Indian Council of the Medical Research, World Health Organizations, they are recommended 300 grams of the vegetables to be consumed per adult per day, but that which we are not getting due to several reasons, due to the bargaining of the populations, due to the post-harvest losses, due to the biotic and the abiotic stresses. So there are so many reasons. So for that, the topic which today I bring over here is for generally for the people, generally for the population of our country who are residing nearby the urban areas and the peri-urban areas. Why I am highlighting the urban and the peri-urban areas? Because the people who are living in the urban and the peri-urban areas are not getting the fresh vegetables, and as well as the areas where belongs to the peri-urban areas and the urban areas, the shrinkage of the land, almost all the cities, see this greater Noida,
previous it was not like that. Everything has been changes as because of the industrialization, as because of the modernizations, as because of the urbanization. The flat sculptures are everywhere in all the cities of our Indian scenario. So for that, it is very, very much essential to give the fresh vegetables of those people who are living in the urban areas. So that is why this soilless farming and this hydroponic farming, I can say, it's coming up very well in present scenario in our country also. In the recent last COVID areas only, we came to know that, as we know, our Indian population is increasing day by day. Till 2025 March, we are in the second position throughout the world for the population. But after 25th of March, then we become in the first position for the world of population. It indicates that how much the population of our country has been increasing. So it has been seen that during the COVID situation, all the people, all the young youth are stuck in some of the cities like Bangalore, Calcutta, Delhi, Mumbai, Gujarat, because the urban population are increasing day by day. The villages youth are coming forward to the urbanization, forward to the cities for getting the job. So if that will be the case in this present scenario, then the urban people are very difficult to get the fresh vegetable as because of the bargaining of the population. So that is the one of the reason why we have to choose the soilless farming, why we have to choose the organic farm, why we have to choose the hydroponic farming. Land fragmentation is one of the major problem. As we know, the average land holding of our Indian marginal farming in eastern part of the country, if I say, the persons may not consider me if I talk about the northern plains of the India, but if you go to the eastern part of the country, the farmers doesn't, the farmers has the less than 1.08 hectares of the land. So within that land, the land's conditions is also very, very much deteriorated as because of the indiscriminate use of the fertilizers, insecticide, and pesticide. The health of the soils has been losing day by day. This is also one of the conditions why, to feed the bargaining population of the urban areas, we have to go to this modern future technology that which we called as a soilless farming or the hydroponic farming. And the one is in water scarcity. Water scarcity is a main problem in the present scenario throughout the world, including our Indian scenario. So in case of the vegetable farming in the open field conditions, the farmers are using the water very, like I can say, without controlling. Most in the vegetable crops technology, the flood irrigations have been adapted. Although in case of the protected cultivation technology, which I also do some of the work in the protected cultivation, drip irrigations we are talking about. But how many farmers of our country are using the drip irrigation? As because they don't have a capacity to purchase the drip irrigation, although the governments are giving the subsidy in some parts of the states, but still now the farmers are not considering the drip irrigation from where we can preserve the water, from where the plants can get the efficient type of the water. So that is the condition of the scarcity of the water. And another thing, the rising of the cost. Fertilizers, inputs, everything, seeds, fertilizers, everything has been increasing day by day. So for inputs, how huge number of the seeds, huge number of the fertilizers will be required for the cultivation of the vegetable crops in the open field conditions. So that can be minimized if you go and cultivate the vegetables in the soilless farming system, as well as this climate uncertainty. You see now in this condition, now the month of the April here in the Noida, I'm getting very much comfortable without the fan in the room. The suddenly, but when I came last year, the April was very hot. So that is what in every way, the climate situation is scarcity, climate situation is uncertainty changes. So as because of that, vegetables cropping sequence, cropping seasons has also been changing in the open field condition. So if we think about to cultivate the vegetables in this systems, we can grow the vegetables throughout the year in a very small space, or a very little space per unit area. We can register more amount, more productions of the vegetables comparison to the rest of the other crops. So that is why I always think about this urbanization and the industrialization, as well as the demand of the foods, demand of the fresh food. So we have to go the soilless and the hydroponic farming. Sometimes some people tell me that, oh, you are doing the hydroponic and the soilless farming. Here also you are using some of the inorganic fertilizers. So if I will use the inorganic nutrient solution in the soilless farming, the hydroponic farming also, if I compare with the open field condition, that is a very minute amount. As a vegetable professor, I can say for growing of the tomato, one plant of the tomato, we can have to apply the nitrogenous fertilizers like the urea, maybe like 3 gram or the 2 gram per plant. It's a rough calculations I'm talking about. That 2 gram or 3 gram of the urea is a very huge. So that when I have to apply the nutrient solution in the hydroponic and the soilless farming system, it will be milligram, that 0 point something milligram. So that is also the toxicity will be the very less. So that is the reason the people who are living in the urban and the peri-urban areas, they are not getting the fresh vegetables. So that's why they have to depend upon the open field conditions vegetables where the full of toxicity will be there in the vegetables. That is why I like to promote the people who are living in the flat cultures, who are living in the cities and the town, having the small unit area, they can grow their own vegetables for consumption of the fresh vegetable without toxicity, by which we can avoid the devastating diseases like the cancers, diabetes, and so many diseases. That is why I always like to promote this hydroponic system. And hydroponic and the soil system, all of you know, is a very not new. But suddenly in our Indian scenario, we talk about, oh, hydroponic and the soilless farming is a new emerging technology. But if you go to the back history of the hydroponic and the soilless farming, since from 600 BC, thousands AD, 1280, that time only the hydroponics and these things are there, which it will imply to this slide. You see, like Babylon, floating garden of Egypt, Mexico. These all are the technology which has been adapted from the long back as a hydroponic technology. And the one fine thing I want to see, these all are the hanging gardens. These all are the technology which has been considered since from a ancient time also. And one thing which I can highlight in our Indian scenario, now everyone is behind the hydroponic. There are so many employment people, and that is the why I add as an employment generation in the urban areas. This is one of the entrepreneurship field nowadays in the horticulture sectors. In the horticulture sectors, previously we feel that preservation sectors, post-harvest sector as a preservation and as a nursery is one of the entrepreneurship business. But now the thing has been changed because the nurseries people are not getting the up to the mark of their product, and as well as a preservative product still now. But now, if I compare with the last 90s to 2000, the preservative product or the processing product are also marketing our Indian scenario. But if you think about like processing product and the preservative product, that is not so very much feasible, and that is not so very much healthy for the Indian people like us. We are not consuming the processed food. But whereas if you go to the European country and like that, they are totally dependent upon the processed food. Although we are now in the post-harvest technology, in the preservative also, we are processed so many foods, but still now, how many people are consuming? There might be the channel, there might be many marketing channel, maybe the shopping mall and everywhere, these things are available, but still now, the consumption pattern is not so very much high. So that is why these things happen. And like the very long back in India, this hydroponic system has been started in my district. Basically, I'm from the West Bengal, but my native place is in Kalimpong. So Kalimpong, my district, is the first district where the hydroponics lab was established 1946 by the English scientist W.J. Salto Douglas, and he established in our area, that is the Kalimpong area, and written a book of the hydroponic, named as a hydroponic the Bengal system. So this is how in our Indian scenario also this hydroponic system has been developed. But now I'm telling you, I did my postdoctoral 2009 and the 10. When I came 2010 in India, I started to work in the hydroponic with my PhD students. That time it is very, very difficult to get the medias. Nobody knows about the cocoa medias. Nobody knows about the substrate. Even the plug tray which we are using, which becomes the very popular nowadays for the raising of the seedlings, is not available. So that is the reason that time I brought the plug tray by train through Bangalore and like that. But the situation has been changed. Everything is in our hands. You can get everything of the hydroponic equipments to hydroponic software to everything in your hands in the online system. So that is why it is very much essential to promote the hydroponic system. So this is a condition throughout the world. Australia, Bangladesh, Bali, even they have started to grow the rice in the hydroponic system also. So this is what in our Indian scenario also hydroponics within 2030 to 40, hydroponics is only one of the future farming which is up to the Indian condition. Each and every growers as well as each and every people who are residing near the cities can have to cultivate this hydroponic system of the vegetables for getting the fresh vegetables as well. So these are some of the reasons, as I told you, salinity, drought, rock, insufficient nutrient availability, abiotic and the biotic regions, industrialization, urbanization. These are the things we have to choose for the hydroponic system. And the advantage for the hydroponic system is that fast growth cycle compared to the rest of the other crops, better quality, no soil-borne disease. Like soil-borne disease is the one of the major factors in our agriculture and the horticulture system, because most of the vegetables which had been released, the varieties which had been released for a couple of the years only, the breeders release the varieties, and that varieties cannot be sustained. Leaf curl virus or yellow vein viral diseases, the disease resistance will be broken down, as because soil itself is a pathogen from where the crops will get the diseases. But if we will utilize the other system in spite of the soil, like your substrate or the hydroponic, there is no opportunity of having the soil-borne disease. That is which is one of the best advantages for the hydroponic and the soil system. And the one is the wheat is a major problem. The wheat competes the crop at earliest of the crop planting growth. So it is estimated that 20% of the vegetable productions has been lost and has been reduced as because of the wheat problem. So if you grow the crops in your water and if you grow the crops in your substrate, there is no chances of the wheat problematic problem also. So that is why these are some of the things which we have to go for the hydroponic system. And another thing which I have highlighted over here is the high value vegetable crops. Why will you go for the high value vegetable crops? I don't suggest to grow the pumpkin in the hydroponic system. I don't suggest the other traditional vegetable to grow in the hydroponic and the soil system. I suggest the high value vegetables crops can be grown in the hydroponic system, as because of the modern food habit changes by the you people, like the students like you. When I think about the long back of the 50 years, my father used to bring like chapati and chola, that which we prefer to consume. But nowadays, you people are very much fond of having the lettuce, like in case of your Domino's, pizzas, pasta and chow mein. So as because of that, if we have to introduce the vegetable for the diversification of our daily diet, then we have to go for the high value vegetable crops like the broccoli, Chinese cabbage, Brussels sprout, lettuce, parsley, and not only that, as a human health consumption pattern also, we have to get the more antioxidant as well as the more nutrient from the high value vegetables comparison to your brinjal or the other nectated vegetables. We'll get the more nutritive value, as you have an idea of almost all the cruciferous high value vegetable crops like the Chinese cabbage, pak choy, and the broccoli and the Brussels sprouts are having the anti-cancer compound which has to be fitted for the present scenario. So that is why for the high value vegetables, we have to go for the high value vegetable crops only. So madam is seeing me. Okay, now in case of the soilless farming, the hydroponic system, first of all, we have to choose about, if I'll go for the soilless farming, then which media we have to use. That and the people sometimes may be very much confused about hydroponic and the soilless. Soilless itself is the hydroponic. Hydroponic itself is the soilless. Only the thing is that in case of the soilless, there are the different method of the cultivation practices. Some may cultivate the crop within the water itself. Some may cultivate the crop with the substrate itself. So that is the differences only. But hydroponic itself is the soilless farming system. So if you want to go the soilless farming system purely, then we have to think about the media. So what are those media? Asparagus mulch is the one media, the common media, cocoa peat, rice hulls, sawdust, vermiculite, perlite. These all are the medias, raw cool, isn't it? Pure mix, and these all are the nowadays which the media are available in the synthetic way. Hydrogel, wood chips, these all are the media. But See, what we have developed in case of hydroponic system, no doubt, is that every crop we have standardized in the grow bag system or the different type of the system, what type of media we have to use. But while practicing the hydroponic system in the grow bag system with the substrate, we realized that the price of other substrate like perlite, vermiculite is very high. Some of the persons of our Indian scenario, they can't afford to purchase that soilless media. It's a very high price. So for that, we think about the vegetable and the kitchen waste as a cost-effective substrate in the soilless farming. So any persons who are living in the cities, having a small unit area, daily in their bucket of kitchen, they will get the vegetable waste and like that. So that we utilize that vegetable waste of all types of the peels and everything, as because it has more organic matter, more micronutrient, more pH regulation. And what we did, we did the diversification of the vegetable. Solanaceous vegetables like tomato leaves, potato peels, pepper stems, again like your legume vegetables, then cucurbitaceous vegetables. So we in the different vegetables in a very like kitchen waste vegetables, we just made a composing way, and that is also very much easy. So fundas of the compositing is now not necessary. Simple. This is a truss bin basket which is available in the truss basket market. It costs about the 1,000 rupees. You keep it in your house, you put all your pills and everything, and you will get the two products. One in the liquid form, which can be applied to kill the insecticide also. One in the compost, and that which we use as a substrate. But basically, sometimes the compost cannot be considered the soilless substrate. But of course, in case of this compost, there will no mixing of the soilless. But there are so many literature in the previous time, vermicompost can also be used as a soilless. But in fact, vermicompost is not a soilless substrate. So in that substrate, we can add. So we have standardized in case of the tomato and the capsicum, 3:2:1, 3 cocoa peat, 2:1 vermiculite, and 1 part of the perlite. But it's very difficult to purchase the pearls, very high prices. So what we did then 3:2 plus 2:2 of this waste material. So like this, we are doing our work and the different types of the system. So this is what I want to highlight it in case of the hydroponic system. So this system, when I purchased the very long back in 2009 for the 32 plants, it cost about 15,000 rupees. Who will purchase for the 32 plants of growing the lettuce and the palak saag and the pak choy for the 15,000? So for that, what we do our own plumber. We have make our own PVC pipe NFT system. Now this PVC pipe NFT system with the 32 plants cost about 1,500 to 200 rupees. So any householder living in the cities, they easily afford and they are very much agreed to come forward to grow these crops as an NFT system. And this is what the different horizontal and vertical. Even the French bean, we know, like horticulture scientists or the vegetable production scientists, they know French bean require very less water. So this was a challenge for me. One of my senior most professors told me, French bean never grows well in the hydroponic system because the leguminous crops like the French bean or pea will require a very small quantity of the water. But what we succeed to grow the French bean in the NFT, in the hydroponic system also. So that is what, this is one of the wonderful findings. And another equivalent to the NFT system of your PVC pipe and like that, one of my students did this in the wastage mineral water bottle with the substrate of vegetable waste substrate and with the pure water. So this is how the palang shak, that is our local Beta vulgaris bengalensis, can be grown very well in the mineral water system also. So anybody who wants to grow this, they can grow with a very cost-effective prices. So that is what, and there are some of the other things which I want to highlight it, but as big, and another, we develop ourselves the floating system. Okay, if you go for your types of the hydroponic in your bookish knowledge and like that, you will not get this floating system. You will get the deep culture system, elbow systems, whatever maybe this floating system. In the floating system, all of you know that for pudina mint loves to grow in the water. Mint loves to grow in the water. In the tray, you put the water and in the upper side, you make your this thing thermocol paper and pinch the hole a little bit, and this way you can go in a very cost effective of the this thing. And another one is the grow bag system. We have standardized all the grow bag system with cucumbers, and this is another floating system. In this thermocol plate, you make a bunch of this thing, and in the tube-like structures, you dock in the mud or whatever maybe, and you can show in a very cost-effective way of these things. And this is what about the lettuce and like that. This is capsicums we have grown because I have limited time. And another thing which we have highlighted that most of the vegetable scientists in those who are working in the cultivation practices and in the horticulture sectors also, everybody feels that green set net is one of the wonderful set net, but that is what it which we have finded that green set net is not up to the mark for the some of the vegetable crops like capsicum, cucumber, and other high value crops like celery and like that. So white set net, which we have standardized, is one of the wonderful. Another which I want to show you the last, that is this frame, like this hydroponic system, whatever maybe the systems, it required in the conditions, not in the open condition. Because if you grow the thing in the open condition, nutrient to mix with like a water, so it requires some setness and like that. So for cultivation, the protect, if the farmers of the progressive farmer, the youth can establish the protected cultivations, then hardly for the 200 square meter also, it comes about the 2.5 to 3 lakhs. The simple one, not the high one. So for that, we have make this frame, PVC 5 frame, and the pulley structures which can be dismantled also. So that why we are doing, because in case of our Calcutta, in the Salt Lake sector, sir, all the retired professors and senior most proper, they are now doing their own as a hydroponic system, but they don't want to disturb their terrace. Because if we make the protected cultivation with, say, it looks odd of our terrace, so that time we have given this, so that after growing of the finishing of the crop, they can dismantle and they can put it. So this is also one of the good farmers. Okay, ma'am, thank you. And another one, so if we talk about the drip irrigation facilities and like that, here in case of the hydroponic system, the grow bag system, simply with this mineral water bottle, just like a drip irrigation facilities, you put the 1 liters of the water, it goes like drip one more than 15 days. So that is what, this is also the cost effective factors. This is French beans. This is what, because the time is very short, so I can't show you all the slides and this thing. And another thing, which in case of this hydroponic or the soilless farming techniques, nowadays it is coming up, is one is the microgreen. So microgreen can also be grown very well in the hydroponic system and the substrate system, which we have already standardized of the different what type of the lights. And this is another one. Even we can use the wastage of this biscuit container or the chocolate container to grow the tomato or even the pudina bean in the very well in the hydroponic system. So this is what, and this another one is the microgreen, which the microgreen comes up also very well in the hydroponic categories. We have standardized the different intensity of the light, which is found to be the more in the hydroponic system. So this is what, like, I don't want to, because in the very hurry, because man is saying it's a, as you know, the time is one of the limiting factor. And this hydroponic and the soilless farming of the my slide, generally I require the more than the 1 hour. Anyway, thanks for all. I tried my best to convince why we have to go for the hydroponic system and the soilless farming system. Thank you very much. Thank you, ma'am.
Sir, please. Dr. Thapa, your passion is infectious, actually. I'm sure in many of the hostels now we'll be seeing students growing their own lettuce for their own burgers and the chow mein and the other savories they have. And thank you so much for such a scintillating lecture and such wonderful images. I'm sure students will benefit from you later on during the lunch and later hours also. Please feel free to interact. Dr. Niveta Jain is the next keynote speaker, and I'm really honored to introduce ma'am to the audience. Dr. Niveta Jain is a distinguished principal scientist at the Center for Environmental Science and Climate Resilience Agriculture, CESPRA, ICR, Indian Agricultural Research Institute, New Delhi. Ma'am is a PhD from Delhi University. Ma'am specializes in the monitoring, mitigation, and modeling of the greenhouse gases, nitrogen losses, and life cycle assessment within the agricultural sector. Ma'am's research is pivotal in addressing atmospheric pollution from crop residue burning and developing sustainable practices, such as water-saving rice cultivation, to reduce the carbon footprint of food production. Dr. Jain's global expertise is recognized through her leadership roles as a lead author for the IPCC and an expert for the UNFCCC. And ma'am has received prestigious accolades, including
the Dr. Rajendra Prasad Puraskar for her extensive contributions to climate change policy and environmental science. Ma'am is a passionate teacher and a very able researcher. Ma'am has almost 7,000 citations, and really, we, ma'am, look up to your wonderful lecture ahead. I'm sure the students will benefit it. Thank you.
Yeah. Thank you, Dr. Shalini, for a very elaborate introduction. Though this session is about the horticulture crops, I'll be talking about the impact of climate change on the crop production and how we should combat the effect of the climate change on the horticulture crops and what are the ways out. So slightly different perspective I'll be talking about. So today's topic is pathways on the low carbon agriculture, which how to combat the climate change and what are the different pathways to decarbonize the horticulture sector during the supply chain. So concerns of climate change are very alarming. As per the IPCC 6 assessment report, we know that climate is changing very rapidly and it is intensifying day by day, which is evidenced by the recent climate. Like in February, we had the heat waves coming into the picture, and then in the March, we had the terminal rain, which is affecting the crop production. And thanks to the human influence in warming the climate, which is impacting to all of us in some way or the other, and it is advocated and it is analyzed that the temperature is going to increase by 1.5 degrees centigrade in the coming years by 2040. The UN General Secretary Antonio Guterres on 1st November 2021 in his address said that either we stop or climate will stop us. It is time to say enough, and we have to take the action so that we prevent the climate change. Now, warming, when we talk about it, is driven by emissions and partly masked by the emissions which we are observing in our day-to-day life. If you see the graph, that we have seen quite a big alarming increase in the warming during the decade. But along with that, we have a lot of emissions from the aerosols and other air pollutant which are leading to the cooling effect, and that is making our life somewhat easy, because if there are no emissions of the aerosols, I'm not saying that we should keep emitting aerosols, but they are preventing the warming or limiting the warming. And if you see the data in the current month, the annual average carbon dioxide emission was 425 ppm with nitrous oxide around 2 ppm, and methane emission 2 ppm and nitrous oxide around 340 ppb. And the temperature has increased by 1.07 degrees centigrade during this period. Now, climate change is aggravating, leading to temperature change and shift in the seasons, shifting the cultivation zones. Like horticulture crops, the altitude is the crops are growing at the higher altitudes, and the rainfall variability is intensifying day by day. We have frequent floods and droughts, cyclones, hurricanes, and then sea level rising and glacier melting is taking place, which is leading to multiple extreme events in the country and across the globe. When we talk about greenhouse gas emissions and the agriculture, if you see the global scenario, that 76% of emissions are carbon dioxide, followed by your methane and nitrous oxide, and remaining other like gases like your chlorofluorocarbon, NF6 and SF6. When we talk about India, our contribution to carbon dioxide is 78%, followed by methane and then nitrous oxide. So in 2020 data, which was submitted in the form of biennial update report by Indian Ministry of Environment and Forest to UNFCCC, the world emitted 50 billion CO2 equivalent, and the
global contribution of agriculture sector is 10 to 12%. Generally, when we report to UNFCCC, it's a FOLU, that is your agriculture, forest land, and other land usage. That contribution is around 24 to 25%, which includes the forest as well as the agriculture sector. And when we compare the Indian emission to the global emission, it is around 6%. Indian agriculture is around 0.8%. So we emit very less compared to the global fraternity. And the food waste, which all of us waste while we take in the plate, we are not judicious while we keep the food in our plates, that contributes approximately 30 to 40% of GHG emissions in the environment. If we talk about Indian economic sector, we emitted around 2.8 billion tons of CO2 equivalent, and agriculture sector is 408%, which is approximately 14%. When we talk about climate and food, the impacts in the food system have very at different level. We have impact on the soil, we have impact on the water, we have impact on the air, and that has a lot of implications. So it's not only we have negative impacts of the climate, we have the positive impacts of the climate also. So everything has pros and cons. The more rains in some area, we benefit if the area is water deficient, and sometimes the increased carbon dioxide also enhances the yield of the several crops. Now, when we see, especially in case of the horticultural crops, we see a lot of frost injury, cold stress the crops are facing. So if the temperature are rising, it is sometimes beneficial for the horticulture crops, and cooler region have the better temperature, better environment to grow more crops. But overall, there are negative impacts. Now, if we see to cope up with all the climate impacts, there several countries, approximately 197 countries have signatory to UNFCCC, and they are, after the implementation of Paris Agreement, all the countries have to ratify it. The difference between Kyoto Protocol and Paris Agreement was that Kyoto was only for the developed countries, and now Paris Agreement is implemented for both developing countries and developed countries. And we have a chronology of India's national commitments. Earlier it was only 30 to 35%. Then later on it was updated that our net zero emissions will be up to 2070 instead of 2050. Then our NDC was further updated that will go for 45%. Then now recently it is updated to 47%. Though agriculture sector is not covered under this, but agriculture sector indirectly contributes to our net zero emissions. Now, for that we have to combat the impact of climate change, we have to align horticulture with our climate goals. How? It is helping us, like our orchards are helping us for the carbon sequestration, emission reduction, and then if we go for the circular economy, we can reduce the waste, and then we move away from the fossil energy. As I told you that agri-food system contributes to the 31%, so we have to go for the decarbonization, and it is estimated that carbon footprint of the per kg fruit is 1.3 kg CO2 equivalent for per kg of fruit production. And the supply chain especially has higher emissions. So we have to think not only the growing or processing, we have to consider the whole supply chain. I will skip this statistics, but would like to maintain that only 3% of our vegetables and fruits are being processed. And we have large number of waste, which is annually contributing to GHG emission, the fruits and vegetable waste. And if we talk about the processing level, vegetable and fruits contribute only up to 8% of the processing. And segment wise, if we talk about, we have both unorganized and organized sectors. So when we have to consider the supply chain emissions reduction, we have to consider both organized and unorganized sector. And we have to take care of processing at emissions at every level, be it primary processing, be it secondary processing, and be it tertiary processing. Every step we utilize different energies, different chemicals, so we have to take care of the emissions at every step, because all these processes are impacting our air, water, and land. So what are the environmental impact of our food system? So when we grow the food, we have emissions, we have pollution to the land, we have pollution to the water bodies. Then for transportation, we are using fuel, so that is leading to emissions. Then we are processing and packaging, that time also a lot of emissions are taking place. And again, we are transporting our processed food, we are contributing to the emissions. Then in the retail and wholesale distribution system also, we have emissions related to the transportation as well as the energy consumption for post-harvest storage. And then again, at the consumption level, we have refrigerators, so we are using a lot of energy there and then wasting a lot of resources. So in the supply chain, we have multiple places where we have energy intensive emissions, energy-based emissions. So we have to curtail emissions at every level. We call about scope 1, scope 2 and scope 3 emissions. So supply chain contributes to approximately 80% emissions, which need to be controlled, but they are harder due to indirect emissions. Over packaging contributes to a lot of emissions, and the impact has to be assessed by life cycle assessment so that we know where are the hotspots. If you see one study by Our World Data, that supply chain contributes to 18% of the food-based emissions. And the study has also done the life cycle assessment of different producers and found that how much emission each product processing and at what place is the hotspot, or what is the process which is contributing more, so that you can go for the mitigation. The key challenges for decarbonization is our fragmented small holding system, poor cold chain infrastructure, and high cost of the technology. And the climate smart system is you have to go for precision farming as per the requirement, efficient water and fertilizer use, and organic inputs. Then go for energy transition, because in the post-harvest system, we need lot of, especially for the horticulture system, we need lot of storage systems. So go for energy efficient system, mainly solar system we can use, so that we can contribute to the net zero target of the country. Then sustainable logistics, so that we can reduce the transport emissions. We go for optimization of the miles which we are procuring our things, and local scoring. We go for the circular economy, which is a need of the hour, like reduce, reuse, and recycle to reduce post-harvest losses, composting and bioenergy using the biogas processes, and sustainable packaging, which has been talked in the morning also. And we can say that waste reduction is one of the fastest way to reduce the emission, because when we reduce the waste, we grow less and we use less fertilizer. So we reduce every aspect of the economy. This is like processing. I can skip here. We have to go for the stronger supply chain, so that because of the changing scenario, changing climate, lot of impact is taking place in every aspect. Because of climate change, we have lot of pathogens, we have lot of infectious disease, lot of mycotoxins are there. To prevent that, we need lot of storage system, post-harvest, better post-harvest management system to protect our food from damage. And that is why we need to invest in the low emissions scenarios, like using the solar energy and renewable energy sources. So for last 2 slides, 4 areas for decarbonization is you need to increase the sink, you go for the material replacement, energy consumption is to be reduced, and then you change the fuel from fossil fuel based to the renewable energy. And future outlook is go for the net zero supply chain, increased investment in the net zero kind of system, and sustainable consumer demand based on the blockchain supply system. And then we need policies so that we convince farmer to go for the low carbon system, and for that we have to have carbon market and public private partnerships. And the conclusion is we have multiple solutions existing in our neighborhood, but we need to integrate everything. And Last thing is that a system-wide change is required to combat the climate change and go for decarbonization. So at the end, I would like to stop by saying that climate goals are achievable. We need to start acting now or the climate will change us. Thank you very much.
Thank you so much, ma'am, for such a smartly managed time. And I'm sure all the messages you wanted to give across to the students have reached the audience. And it was a wonderful lecture, followed by ma'am's excellent keynote address. We now have invited talks. And the first invited talk is by Dr. Anna Ekuzena Gongoles Coloma. Ma'am is Senior Scientific Researcher at the Institute of Agricultural Sciences in Spain, where she leads the research group Biopesticides, Biotechnology, and Chemistry of Natural Products. Her work centers on the discovery, optimization, and biotechnological production of botanical and fungal biopesticides, integrating chemical ecology, natural product chemistry, applied phytochemistry, and microbial biotechnology. Dr. Gongoles is internationally recognized for advancing sustainable pest management solutions based on natural metabolites from endemic plants, agricultural residues, and endophytic fungi. Ma'am has earned her PhD in biological sciences at University of Madrid and held postdoc positions at the University of California, Los Angeles, and Hokkaido Agricultural Experimental Station, Japan, before joining the CSIC. Ma'am has published more than 200 peer-reviewed articles, 14 book chapters, and holds 11 patents. 5 of them are licensed, along with a licensed plant variety. Ma'am has supervised 15 PhD students, 27 master's theses, and led various research initiatives, including national and international projects, life environmental projects, and industrial collaborations. Ma'am is actively involved in scientific dissemination, serves as treasurer of the specialized group on natural products of the Royal Spanish Society of Chemistry, and frequently participates in international conferences as an invited or plenary speaker, organizer, and scientific committee member. Ma'am, we are indeed privileged to have to listen to your words, and we have a very keen audience. But due to the restriction of time, kindly pertain to 10 minutes, if possible.
Good morning. Can you see my screen?
Yes, ma'am, we can see your screen and listen to you also.
Okay. Okay. Good morning from Spain, and my talk is directed to the pesticides problems and innovative solutions in the context of the European market. Before I start with the talk, I want to introduce my institution, my research institution, which is the Spanish Research Council, which is a countrywide institution that covers the entire geography, and we have 120 research institutes. My institute is within the agricultural science area because our institution covers all the scientific areas and also other areas that are not scientific. The question is, are pesticides necessary? They're necessary to protect cultivated plants from pests and diseases. Otherwise, the crop losses will be between 30 and 50%. But the pesticides, as we all know, harm people, other organisms, and the environment. Therefore, we need to find solutions. However, the real need of the pesticides is sustained by the market. Insecticide market growing at a rate of 9%. The herbicide market is 6.14% and is the largest segment of crop protection chemicals needed across all regions. The fungicide market is also very big, growing at 5% this is a forecast until 2029. And the miticides market is 4% increase. Because what is this? Because there is a real need of these compounds. given their harmful effects, the European Union issued a pesticide regulation starting in 2009. But we can divide this regulation in two periods, 2009 to 2024. In 2009, we got the directive that introduced the sustainable use of pesticides and mandatory integrated pest management. In 2020, they issued the Farm to Fork strategy and proposed a regulation aiming at 50% reduction on chemical pesticides of 50% by 2030. But in 2024, the sustainable use regulation was withdrawn. So the core regulation science hasn't been unchanged, but still the regulation has changed. So what's going on after 2024? There is no European-wide legally binding pesticide reduction targets after the withdrawal of the sustainable use regulation. The reduction nowadays is driven through withdrawal of mostly based on the non-renewal of active substances, because so many of the active substances are being withdrawn, and that's a kind of regulation. And we also have a stricter approval criteria, an updated EFSA guidance increasing regulatory pressure, but that's very similar to the one we had before 2024. On the positive side, we have an expansion of the raw risk and biological plant protection products because of the lack of new substances and the withdrawal of the substances. We have a greater reliance on integrated pest management because of the previous regulations. And we have an observed market changes and even across member states, because each member state is a little bit different. But in Spain, we have a very agricultural economy, and therefore we have a very strong position on this issue. Therefore, new natural pesticides are needed. Why? Because the chemical active substances are progressively withdrawn or restricted. Even regardless of the lack of reduction targets, there is a continued pressure to reduce risk and dependencies on chemicals. Crop protection gaps are emerging due to limited chemical options. Biological and natural pesticides are better aligned to the low hazard cutoffs. Their natural substances are compatible with integrated pest management and agroecological strategies. And those substances are key enablers to reconcile food security, environmental protection, and the European Green Deal objectives, which are still in force. Therefore, there is a need for effective and safer alternative products, which are biopesticides that can come from plants and microorganisms. And we are focused in my research group on biochemical biopesticides based on natural products for controlling crop pests and diseases. The advantages of biopesticides are lower toxicity, affect mostly on the target pest, less persistence on the environment, and they can be used in integrated pest management. This is my research group, the biopesticides group, and we work on natural compounds for crop protection based on plants, agricultural waste, and endophytic fungi. The rationale under this hypothesis is that the approach is the plants and their endophytes are chemical factories. Secondary metabolites are plant defenses, and their study allows us to find natural solutions for plant protection, either from the endophytes or from the plant itself. So I'm going to give you an overview of what we have been working over the years. We've been working on active plant products, and we selected endemic plants because we figured that endemic plants are reservoirs of new chemicals with interesting activities. For example, the tree Persea indica, which is a paleoendemism of the Canary Islands in Spanish territory in Africa. We found ryanodines, which are very selective and strong insecticides against insects like Spodoptera litoralis and Polyphagus lepidopterus. We also worked on this species Betancourtia palmensis, which is an endemism from a restricted genus only to the islands, We found sesquiterpene sylphenenes, very, very efficient as selective insecticides acting on GABA receptors on chrysomeliid beetles. Lavandula luiseri, which is an Labiaceae endemic of the Iberian Peninsula, containing necrodennes, which are unique to this genus within the Lavandula genus, and they're found defensive signals against insects, and they are effective acaricides and herbicides. Continuing with the plant products, we also work on agroforestry residues, for example, from the production of garlic oil. As in comparison with a company, Copaman, we have studied the residue, the hydrolate. The hydrolate is the water residue after the essential oil extraction in the industrial plant, and we have discovered new non-compounds and new compounds acting as nematicidal agents, very strong nematicidal agents. And the variety that we worked with was the purple garlic, which is a national Spanish garlic variety that is high quality. We have also worked on pruning and pruning waste from forestry residues. For example, from juniperus, Spanish juniperus, from the pruning residues, we found essential oil and extras rich in acaricidyl sesquiterpenes such as cedrene, tuhopsen, sidrol, noctacon, burolene, imachelene, and also from the euthanolic extracts of eucalyptus leaf residues. We have active ingredients acting on aphids, and this was developed with companies. We also have a patent on the residues of the cultivation of crocus, saffron. Saffron is cultivated in Spain, and the residual bulbs, which are not good enough as seeds, we obtain quincenosids, new quincenosids, which are very effective as insecticide agents. And from the production of olive oil, which is a high product in Spain, we are the largest producers of olive oil in the world, but this production generates an incredible amount of residues, solid residues from the centrifugation systems to extract the oil from the fruit. So what we did is, in collaboration with a large producer of olive oil and the bio transformation of this residue, we have obtained, which is alperugillo is the residue, we have obtained nematicidal and insecticidal products against aphids from this biotransformation of the residue. Going to the objective of endophytic fungal active products. Endophytes are the microorganisms, fungi, that live within the plant tissues without damaging, and they also produce chemicals that are protectors of the plant, of the host plant. So from Persea indica, we isolated a large number, or we have isolated a large number of endophytes, but we have focused on Philosticta species, which fermentation gave deoxolananes, and which are very active against nematodes and aphids. We have patented and transferred these results to a company. From Bettencourtia palmensis, which these are the same plants that we studied before as endemic, we have isolated also a large number of endophytes, but from the Aspergillus species, one of the Aspergillus species, endophytic species, we isolated neoaspergillic and hydroxyaspergillic and melain. Aspergillic acid and related are antifungal, and melain is acaricidyl. From Artemisia absinthium, we have isolated Stemphylium species, which fermentation gave stepholones and stemphol and are very active against aphids. And this was also patented and published recently. According to following with this objective, we have also used cultivation methods for the endemic plants because they are not abundant and they're protected. So we have used aeroponic, we have used in vitro cultivation, and we also have domestication and upscaling of plants in the field. From the aeroponic, we have worked on Persea indica, the previously shown plant, and we have isolated new compounds from the root parts which were not studied before. We have also worked on the Bettencourtia hermosae, which is a very, very protected, highly protected species, and we were able to isolate highly active aphid control African anise from the Artemisia granatensis, another very endangered species. In vitro cultivation and allowed us to obtain acetylens, which are very effective agents against aphids. And also we have domesticated and registered a variety of Artemisia absinthium in the field, which produces an essential oil which doesn't contain any dujones, which are toxic, and is very effective as a fungicide.
I'm sorry to interrupt.
Hydroponic also allowed us to cultivate other endemic plants like Artemisia pedemontana, Nepetateidea, in vitro, Pericalis, which are all protected and endemic species. Domestication plant scaling, we also applied to Geranium macrorhizum, which is a medicinal plant very effective against ticks and aphids. Satureja montana has been also cultivated, and which is a Labiaceae endemic from the Iberian Peninsula, with very strong effects against ticks, aphids, and nematodes. And also Lavandula lucieri, which I shown before, has been domesticated after a long period of trials, and now we can be cultivated in the field for the production of this very effective essential oil with necrodanes. We also have an objective of biotransformations and modified fermentations to improve the content of the active compounds in these extracts. For example, from the Bettencourtia hermosae, the transformed roots, using transformed roots, we increase 6 times the activity of the compound isolated. Biotransformed with Mucor plumbeus. We took the major African ane, and the biotransformation gave us a compound which was 6 times and 2.5 times more active. For example, from the SPH2 endophyte, we have improved the fermentation, the content of the nitroaxyspyric using supports for the fungal fermentation. And we could also increase the content in melanin, improving the fermentation method. New applications, we are working on phytoimmunization, for example, with the essential oil from the Artemisia absinthium cultivated. We treated tomato seeds. We did a tomato seed coating, and the plants germinated after the tomato seed coating were infected with fusarium, and what we found is what the pre-treated seeds resulted in resistant tomato plants against fusarium. And we also found that there was a metabolic response in the treated plants along with the lipid metabolism. So basically what we are looking now is for phytoimmunization effects of our active ingredients. Also, we have new applications in our as an objective, for example, adapted formulations and synergism. What do I mean by that? We also have niche applications. One niche application is the cultivation of truffle. Black truffle is a very highly appreciated food ingredient in Spain, in Europe in general. It's also a niche cultivation because it's cultivated in the forest in very rural areas where there is no many other possibilities of production, but it's a very high cash crop. The definition is this is a cash crop, very, very expensive. But nothing happened until recently that this pest, Leiodicina momius, is depleting around 40% of the production of black truffle. Why? Because this truffle was before was only wild, and now it's cultivated. There is a lot of truffle available for the beetle, and the beetle now has a large population because of that. Therefore, we needed to develop a control method. What we are doing is essential oils, new synergistic combinations, and adopt formulations, solid formulations to incorporate in the soil where the truffles are growing, but cannot interfere with the growth of the truffle or with the flavor of the truffle. So this is what we are developing now with in the context of PhD thesis.
Kindly conclude, ma'am.
Okay. In general, what we have a transfer of technology, contracts with companies, and intellectual property to transfer these results to the society. And I want to acknowledge my colleagues from the plant production department in Aragon and my group, the biopesticides group, with my colleagues, my students, and my technicians. Thank you very much.
Thank you so much, ma'am. I'm sure the findings, each and every slide of yours took many years of study to bring it about and decipher the structure and the functionality. And our industrial partners' eyes are really glued to your slides and seeing the industrial applications. So I'm sure we are all left enriched. Ma'am would like to thank you.
Sure.
Thank you, Adu. Hopefully see you in November.
Yes, yes.
She was supposed to be here in India, but because of this geopolitical situation, she had to cancel the trip. So we are looking forward to your trip, Dr.
Yes, me too. Thank you very much, Nutan.
Thank you, Dr. Koloma. It was wonderful listening to your words and awesome work. I'm really impressed. We are all impressed, actually. Thank you. Next, moving on to the next invited talk, we have really a wonderful speaker from Thailand, Dr. Patavarti Subthong Nakmi. She is a dedicated Thai plant scientist and natural products researcher at Kesetsart University's Sriracha campus. With a strong passion for harnessing Thailand's rich biodiversity for sustainable applications, Dr. Nokmi has built an impressive career bridging academia, research, and international collaboration. Being a PhD in biodiversity and natural products from Leiden University, the Netherlands, in 2007, her doctoral work focused on antifungal compounds from teak sawdust, laying the foundation for her lifelong interest in bioactive plant metabolites. Dr. Nakme has led more than 15 funded projects exploring Thai medicinal plants, including cannabis sativa, for medical and cosmetic uses, Melaleuca cajuputi as a natural bioherbicide, and plant extracts for antifungal applications in sericulture, wound healing, and food safety. Her work has resulted in practical innovations such as eco-friendly cleaning agents, bioherbicides, bioactive balms, while contributing to environmental solutions like wastewater treatment using native aquatic plants. Dr. Nokmi has authored the widely used Thai language textbook Principle of Biology in 2014 and has published several research articles in international journals. Ma'am has received several honors, including the Jeffrey Harborne Award for the Best Short Lecture at the Phytochemical Society of Europe, the ASEA Uninet Staff Exchange Scholarship for Research in Austria, Kesetsert University Sriracha Campus Researcher Award in 2008. Ma'am has served as leader in the leadership positions like Dean of Faculty of Science in Sriracha, Assistant to the President in International Affairs, and currently as the Vice President of the Netherlands Alumni Association in Thailand. Her work exemplifies the seamless integration of scientific excellence, sustainable development, and international partnership, making her a valued voice in the natural products research and green evolution. Ma'am, we look forward to listening to you and seeing your great work. Due to paucity of time, please limit your lecture to 10 minutes, please. Ma'am, we can't hear you. Welcome, Dr. Nokmi. You can start your lecture and please pertain to 10 minutes. Our students are eager to listen to you. We can't listen to you. You're not audible, ma'am. Ma'am, you're mute, I guess. Can't hear you, ma'am. नहीं आ रहा आवाज बोलिए इनको Ma'am, we can't listen to you. We can't hear you. We can see your slides moving, but unable to hear you. Rejoin करने के लिए बोले? Rejoin करने के लिए बोले? Ma'am, we can't listen to you. Maybe in the settings of Zoom, you have to modify something. Would you like to join again, ma'am? Can we proceed to the next lecture meanwhile? Dr. Andres has joined. अगली वाली Ma'am, can you please rejoin again? Maria Andres. Ma'am, are you able to listen to me? Can you say yes, no? Okay, so maybe you can rejoin again and then we can look for the connection once more. And perfect. So I'm starting with the next lecture. And meanwhile, you can join again. Can you please leave and then rejoin? We are starting with the next session. The next invited talk is by Dr. Maria Andres. Dr. Maria Andres is a research scientist and deputy director since 2018 till 2023 of the Institute of Agricultural Sciences of the Spanish Natural Research Council, CSIC. Dr. Andres has received her PhD from the Autonomous University of Madrid in 1986 and worked as postdoctoral researcher at the Institute of Agricultural Nematology at the CNR in Bari, Italy. She has over 40 years of experience studying plant parasitic nematodes with a focus on their epidemiology, host interactions, and control methods, with the primary objective of establishing the management strategies for them in the 21st century agricultural systems. Since 2002, she has been part of the ICA-CSIC group Biopesticides, Biotechnology, and Chemistry of Natural Products. Her research focuses on development of new technologies for the control of phytopathogens and insect pests through the optimization and biotechnological production of biopesticides of botanical and fungal origin. This work has been carried through numerous national projects, 12 international projects, and 24 R&D contracts. She has authored more than 100 scientific publications, co-edited 4 books and 12 book chapters, and author of 20 dissemination publications. She has 6 patents, 3 of which are licensed. Ma'am, we are really honored to have you amongst us. And we have a keen audience listening to each and every word of yours. But due to paucity of time, I request you to please limit yourself to 10 to 12 minutes, please.
Okay. I will start. Good morning. Thank you very much for your invitation to participate in this important conference. I will show how byproducts such hydrolytes, pyrolysis products, and olive oil meal residues can be transformed into effective tools for the control of root knot nematodes.
Ma'am, can you put it on full screen mode?
Sorry?
Okay, ma'am, please proceed. Please proceed. Yeah.
Root knot nematode. I can continue? Sorry. Okay. Root knot nematodes are among the most destructive plant parasite nematodes worldwide. There are sedentary endoparasites that infect plant roots, inducing the formation of characteristic galls. This nematode parasitize thousands of plant species and cause several yield loss, especially in intensive horticultural systems. The most important species are Melidogyne incognita, Javanica, Arenaria, Apla, and in Spain, their impact is particularly significant in protected horticultural crops. The control of root knot nematodes is extremely difficult. They have short life cycle, high reproductive rate, and can rapidly rebuild population after treatment. At the same time, the European Union is progressively restricting the use of chemical nematicides due to environmental and human health concerns. As a consequence, there is an urgent need to identify 9 new effective and environmental friendly solutions for nematode management. In this context, our research focuses on natural products obtained from our forestry works. We explore residues that are already generated at large scale and often represent an environmental problem. We specifically investigated 3 types of materials: hydrolytes from essential oil production, pyrolysis products such as biochar, and residues from olive oil manufacturing. We evaluated hydrolytes obtained from essential oil production from several aromatic plants domesticated and cultivated in Spain. This included species of Thymus, Lavandula, Artemisia, Satureja, and Allium. These plants are rich in secondary metabolites associated with antimicrobial and pesticidal activity, making them highly suitable candidates for nematicidal screening. Hydrolytes are aqueous byproduct generated during steam distillation of essential oils. They are usually discarded for or used for low-value application, despite containing water-soluble bioactive compounds. Our objective was to determine whether these hydrolytes could be reused and valorized as nematicidal products. We first evaluated the in vitro nematicidal activity of hydrolytes against second stage juveniles of Melidogene javanica. As you can see, most hydrolates cause very high mortality rates, reaching up to 100% within 24 to 72 hours of incubation. This demonstrated a strong direct toxic effect on juvenile nematodes. We then compared the activity of essential oil, hydrolates, and organic fraction obtained from the hydrolates. As you can see, hydrolates showed nematicidal activity similar to or even higher than those of essential oil. This finding is especially relevant given that hydrolates are worsted products, are obtained in large quantities, and are therefore significantly cheaper. Chemical analysis allowed us to identify key active compounds responsible for the observed nematicidal effects. This included thymol, carbacril, diallyl disulfide, diallyl disulfide, and oxygenated terpene derivatives. Beyond juvenile mortality, we also evaluated the effects of hydrolytes on egg mass hatching. Most treatment caused a strong inhibition of juvenile emergence from egg masses. In some cases, hatching suppression exceeded 90%. This is particularly important as it indicates that hydrolates can disrupt the nematode's life cycle at multiple stages. Hydrolates also reduce the infectivity of Melidogene javanica juveniles. Treated nematodes with hydrolate at sublethal concentrations showed a significantly lower capacity to invade plant roots. This reduction in root invasion further supports the potential of hydrolates as multifunctional nematide agents. The hydrolates were subsequently evaluated under greenhouse conditions on tomato plants. Hydrolase treatment caused a significant reduction in the number of egg mass per plant, total egg production, and the nematode reproduction rate. Importantly, no phytotoxic effects were observed. In addition to hydrolates, we investigated pyrolysis products obtained from plant residues, specifically biochar. We have experimentally demonstrated in tomato plant that the application of biochar derived from winery waste showed a significant suppression of the nematode population. Finally, we are exploring the nematicidal potential of olive pomats, a significant waste product generated during the olive oil production. Following biotransformation by saprophytic fungi, phytotoxic compounds were reduced, and the transformed material has proven to be a source of nematicidal stress. In conclusion, this work demonstrated that agroindustrial byproducts can be transformed into valuable tools for nematode control. Hydrolates, pyrolysis products, and biotransformed olive meal waste offer effective and sustainable alternatives to chemical nematicides. Furthermore, their valorization contributes to circular economy strategies and environmental friendly agriculture. Thank you very much for your attention.
Thank you so much, Dr. Andres. Really a very smart presentation and wonderful work on nematocidal applications of the horticultural waste. Thank you so much. And we are not having any question answer session, ma'am, for now because we are running late. We might have it later. And thank you so much once again. Dr. Nokme, are you able to? Yeah.
Try again. Do you hear me?
Great, great, great. I think we just a little we can hear you. We try.
Now you can hear me, right? Can you? Excuse me, can you hear it?
Yes, ma'am. Now we can hear you.
Okay, thank you so much.
Can you please just highlight the salient findings in 5 minutes, please? Sorry, but,
What did you say?
I said, can you please highlight the major findings in 5 minutes, please?
I have to wait, right?
No, ma'am. You can please proceed and wind it 5 minutes.
I can share my PowerPoint then. Okay, is it okay? Is it okay?
It's okay.
Okay, I can start my talk, right?
What we are requesting is to summarize your results in 5 minutes.
Okay, thank you so much for giving me an opportunity, and hello to Dr. Nutan and everyone in Amity University. Really missed to visit you again. Today, my talk is related with another two doctor or professor from Spain that they talk about natural herbicides or natural products for anti-weed or weed control and for anti-microorganism. So this is the harnessing of the bioherbicides potential of Melaleuca casuput, a sustainable approach to weed management and forestry utilization. Melaleuca casuput is a tree that located in tropical forests, not only Thailand, but Southeast Asia and Australia also. Normally, they are at the beach forest and somewhere at the mangrove forest close to the beach. And these trees are able to propagate. So what we found now is that this group of trees has been destroyed by cutting of the forest and use the wood for many purposes. And people go there for camping, and they also make many roads when the city expand to the beach. And this is a photo at the east part of Thailand. And as we would like to focus about the benefit of natural products, so the goal of the research is that finding the bioactive compound from this plant, and this plant is actually in the family Myrtaceae, is the same family of eucalyptus. And then people will know that the main compound in this group of plants is the essential oil. And the major essential oil that affect for other microorganism is the group of terpene mainly. So the plant natural product is the goal for antimicrobial, antipesticides, allelochemical properties, and herbicides, of course. Allelopathy effect is effect to other organisms, not only the plants, but also bacteria, fungi, and any organisms. So the goal of the work is that to find in the system of natural products, not only inhibit the plants or the weed species, but it can also inhibit the plant pathogen. For example, Fusarium oxysporum as a soil-borne fungal pathogen cause wheel rot or root rot in many plant species. So we check and we test the inhibition of Fusarium oxysporum as well. We also check the inhibition of bacteria such as E. coli, which is the bacteria that contaminate in food and water. And the results show amazing that even though it's not directly or no, not fast effect to inhibition of microorganism, but time lag a little bit for 12 to 24 or 30 hours, depend on bacteria or fungi, that Melaleuca cajeput extract inhibit those bacteria and pathogenic fungi. And inhibition higher than the positive control for fungi and bacteria as well. For example, this photo show E. coli at 24 hours. The plant extract inhibit better than the chemical drug. And the next photo here, you can see the blue color compared to the orange. The blue is Melaleuca cajeput extract, and the orange is the chemical drug. And after 30 hours, Melaleuca cajeput give effect to the inhibition of Fusarium oxysporum. So this is the way of the natural compound that sometimes you have to wet them. You cannot just use and directly affect to the inhibition or the activity. But of course, the compound in the plant extract are mostly safe for environment, safe for human, animals, water, and of course, agricultural product. That is the concept idea. So for the weed control, we check many different weed species, especially the weed species that grow or contaminate in the cornfield. And we found the good result. So from the plant material, using in the lab, we can do the extraction, but using in the field or the pot experiment, we can use both the dry powder or the extract. It depends on how big of the area and the price. Of course, it will be cheaper if you use the dry powder put on the soil in the field instead of using the extract. But anyway, from this experience, you can see also the pure compound can inhibit, and application use can use the pure compound that's not expensive. So the experiment start from the plant material extract and test for inhibition screening of the weed and check phytochemical constituents in the plant extract. And of course, go to the major compound, marker compound, or the pure compound, checking inhibition of the weed. And then test on the soil-based experiment and in the field. Statistical analysis will use to prove or confirm the result that the effective is good to use for the application or not. In the result, this photo said on the left hand is the inhibition in the lab experiment, and on the right hand is the inhibition in pot experiment. From A to D is the branch extract, the waste from this plant. And from E to H is the leaf extract and the leaf powder. So you can use from the experiment, you can use both powder and the extract. As you can see at the photo G is the 6% of the powder, leaf powder, compared to H is the paraquat dichloride, which is the herbicides that banned from Europe and many countries. You can see the 100% inhibition from natural product. That is not all the plants can show this, but this plant is really, really special. So this is the photo to prove that the plant extract can inhibit both broadleaf weed and narrowleaf weed. It's amazing that for narrowleaf weed is inhibit with the orange line at the graph on the right hand until 100% when you increase the concentration from 0.1 to 1 gram. And corn is also narrowleaf plants. It's not inhibit corn in the field experiment. And of course, when we check the volatile compound from the essential oil of this plant leaf, we found many different terpenoid compounds as in the table on the right hand. So we pick up eugenol, which is report for mechanism of action like inhibit photosynthesis of plant respiration and also effect to the plant cell growth. Then eugenol show good activity for the inhibition of this weed species, Acanthurus aspera. And the inhibition with 0.1 molar is about 70 to 80% inhibition of seed germination, shoot growth, and root growth.
Please conclude.
And other results show that from 2% to 6% of leaf extract, leaf powder compared to branch of the tree, branch extract and powder, we found the good inhibition with the leaf extract and the leaf powder compared to paraquat dichloride, 0.2%. So the result was very perfect for using in the field, but if this plant is really rare to find, we can grow them. So the discussion of the research is that Melaleuca cachuput is able to inhibit bacteria, fungi, pathogenic fungi of the plants and weed species. And compound in Melaleuca cachuput that mainly is in essential oil as terpenoid, and eugenol is one of the compounds that show activity. You can choose compound, pure compound eugenol, you can choose terpene, you can choose dry powder for application. However, plant has variation of chemical substance inside. So picking the leaf and the plant from different area, like I use from the east and the south of Thailand, is different chemical constituents. And we can find other synergistic compound, as in our summary that we can also have other synergistic compound that give an effect for the inhibition of bacteria, fungi, and other weed species. So natural herbicides, natural anti-pathogen will be good for agriculture, good for organic agriculture, safety agro-industry, and safety food. This is the goal of using natural products for agricultural and food. And some more other experiments will be done for geographical distribution of the plant, give different or biodiversity of chemical compound inside that it need to study more, and reforestation to grow the plant and use their waste and like the leaf or the branch or the bark in other plants to use as this waste plant for being applied to agriculture. And of course, for organic approach, and even though for cosmetic and cosmeceutical product, this plant can use for balm, for lotion, for anti-acne. So the goal is the natural compounds in the plants can apply for many different purposes. And for agriculture, of course, it is possible. And last but not least, I would like to introduce the graduate school program of Kasetsart University, Thailand. If you're interested to visit us or study or do the research with us, please visit our graduate school website or master program in natural product science and technology, master program in bioscience, PhD program in bioscience that relate from Sriracha campus, the East, and in Bangkok as well. We work together, and Kasetsart University is the knowledge of the land. Thank you very much for your attention.
Thank you so much, ma'am. It was a very enlightening lecture, and all the students and faculty members, they are really intrigued by the findings and hoping to replicate your research with our natural resources. So with this, I would like to conclude the session on climate resilient horticulture, urban and backyard farming.
Thank you. Sorry, ma'am. Thank you, for joining. And sorry about this. We are running a little late, so there will be no question and answer. So maybe when you are visiting India at that time, we can have detailed discussion with you. Thank you so much. Thank you for joining.
Thank you so much, everyone. Thank you, Dr. Nathan.
Thank you.
To conclude the session 4 of this international conference, Climate Resilient Horticulture, Urban and Backyard Farming. In this session, we had 2 keynote lectures, one by Dr. Umesh Thapa on the hydroponics cultivation, and I'm sure his passion is infectious, and many of you are now interested in carrying it forward. The second keynote address was by Dr. Niveta Jain, who emphasized on the life cycle assessment of the food processing sector and gave us the key takeaways on how to reduce the greenhouse emission. We had three very nice, very well researched and years of accumulated experience shared by three keynote speakers. Dr. Acuzena Gonzalez Coloma from Spain, Dr. Maria Andres from Spain again, and Dr. Patwardi Sumthong Nokme. And their work on the nematocidal and the insecticidal compounds derived from horticultural waste and food processing waste and the natural resources is really inspiring, and I'm sure many of us are looking forward to working on the same lines and that those levels of excellence which they have achieved. We will not be having any oral presentations as of now. We'll be shifting that to later because of the delay in the sessions. We'll proceed to the uh, next sequence of events. Dr. Devi, please come.
Thank you so much, ma'am. So now we'll move on to the felicitation. I request Dr. Nutan Kaushik ma'am to kindly felicitate our session chair, Dr. Salini Gorudra, as a token of gift for appreciation. And also I request Dr. Nutan ma'am again to kindly felicitate Dr. Nivita Jain, the keynote speaker of our session, the gift, the token of appreciation from our ICRAHOR 26. Yes, sir. So with this, we have concluded the session 4. Right now, we'll have a lunch, and the lunch is we'll be having only 30 minutes. So you have to come at 3:20, and simultaneously the session 5 will be running here. So I'm requesting the faculty and the student to kindly have a lunch. After 3:20, please be assembled here, and simultaneously we'll be having a...
The next session will start at 3 o'clock, okay?
Yes, ma'am. Abhishek sir to मैंने... Yes, ma'am.
अभिषेक को 3 बजे सेशन स्टार्ट कर देना, लोग आते रहेंगे ना, सबका लंच हो गया ना, ठीक, और तो दोनों तो हमारी एक होता है तो बैठ पर
Now resume the session of the ICRAHOR 26. So we move ahead to session 5, Horti Entrepreneurship and Startup Success Story, a session that highlights innovation, enterprise, and real-world success in horticulture. To begin this session, may I respectfully invite our session coordinators, Dr. Abhishek Sharma and Dr. Priyank Sharma, to kindly take the session forward. And I will also like to invite our rapporteurs, Dr. Nikhil Chandel and Dr. Chetra, who will be documenting the proceeding of this session. Over to you, sir.
Thank you, Dr. Devi, and welcome to the session 5, Horti Entrepreneurship and Startup Success. But before we start, I would like to invite our chair of this session, Dr. Ram Asre sir, and our distinguished speaker, Dr. J.R. Ansari on the dais. Haughty entrepreneurship is a buzzword, and we already had a session yesterday in the form of pitch competition where we listened to some of the young minds. And if that was an appetizer, this is a full course meal where we have invited the distinguished innovators of the field. But before we introduce the speakers, I would like to introduce our session chair, Dr. Ram Asre, who is working as a principal scientist and professor. So we have already introduced him, and so I would like to request the chair to take the session forward.
So good afternoon to you all. In this session, we have two keynote addresses by Dr. Ansari, followed by Dr. Jaffrey, and after that we have two more talks, invited talks. So I request to all the speakers and keynote speakers kindly save the time. For keynote speaker, 15 minutes have been allotted, and for invited speaker, 10 minutes each. So please stick with the time. Our keynote speaker, Dr. Ansari, is a well-celebrated scientist in the area of quantum dot and organic framework. He has published several top-notch research papers in a very respected journal. Presently, he is the working professor in Angsi University, South Korea. So, with this brief, I request Professor Ansari, please, to start his talk.
Thank you, Professor, for your nice words. Okay. So, myself, Dr. Ansari. I'm working at Yonsei University. So, here we are going to start a talk which is related with your zero-dimensional, two-dimensional nanomaterials, and that we are incorporating in the polymers to enhance the shelf life of the product. And you can see in the background, this is the university covered all with snow. Okay. So, first of all, let's have a brief idea about what are the various applications that we are having with quantum dot, nanomaterials, nanoparticles, carbon quantum dots, and all. See, these are some of the applications where we are using these nanomaterials to enhance the properties. And of course, we are having in the fertilizer field also, we are using this quantum dot to enhance the time duration, as well as in pesticides also we are using. And these are some of the other applications. These are some of the applications where your quantum dot nanomaterials are being used. And apart from that, there are many more applications. Okay. So let's talk about two-dimensional first. अच्छा, शेयर कर दिया। नेक्स्ट करता हूँ थोड़ा सा। फुल स्क्रीन शेयर कर दूँ। Okay. So, like graphene, we are having another two-dimensional materials. It is molybdenum disulfide. And since it is a kind of semiconductor, we can basically tune the band gap in case of MOS2. And it's not going. Achha, okay. Okay. So this is a monolayer kind of sheets made of MOS2, and it is having a lot of various applications. The difference between graphene and MOS2 is that graphene is having a monolayer of carbon only, but in case of MOS2, we are having molybdenum tangled with sulfur atoms. So that makes a difference, and it is having a very direct band gap. So we can basically tune the property. So that is the difference. That is why we are considering molybdenum disulfide over graphene. Okay, if you are talking about morphology के देखने में MOS2 कैसा लगता है, तो we are having various kind of morphologies. It can be nanosheets, nanotubes, nanorods, quantum dot. We can have various kind of a structure depending upon exactly how we are preparing. And if we are talking about applications, apart from food packaging, photocatalysis, we are having a lot of applications with these kind of materials, and people are using in almost various fields. Now over to quantum dots. If we are talking about quantum dots, we can see the same quantum dots, just varying the size, can show you different kind of emission. Here we can see at 365 nanometer of exposure, we can see blue color. That means the size is less than 3 nanometer, 1 to 3 nanometer. And depending upon the size, we can have green and red emission. So these kind of quantum dots are prepared. Important thing is that here we can see, just try to understand with an example. If you are having a particle of 3 nanometer, another particle of 1 nanometer. So the difference is that the surface to volume ratio is enhanced. In case of a bigger particle, the surface to volume ratio is 1:2 only. But in case of a smaller particles, it is 6 times. That means you can properly enhance. Let's try to understand exactly what happens. This is an ice cube of 10 nanometer. If it starts melting, what will happen? It will cover some surface area. Further, if it melts, its size is 2 nanometer. And in case of very smaller size, of the level of angstrom, you can say atomic scale, we are having a very wide surface area. This is basically the principle and the concept of quantum dots. That means here all the electrons are there on the surface. We don't require additional energy to excite the electrons, and we can very efficiently use this kind of nanomaterials and quantum dots. See, this is your atomic model, and we can see the distance between the nucleus and the electronic shell. That is known as Bohr's radius, and the size of the quantum dot is confined to that level. Just imagine. But with the help of transmission electron microscope, we can see, okay, your particle is 1 nanometer or 2 nanometer. Okay. Another thing is band gap. If you are having a number of particles, the band gap is small. But if you are having 1 or 2 particles, the band gap increases. So the advantage of quantum dot is that we can basically enhance the band gap, and by doing this, the excitation of electron becomes faster. Okay, now this is about your quantum dots. Now, next thing is that we can basically modify the surface, because if we are talking about carbon quantum dot, we are having carbon on the surface, and if it is modified, we can have different kind of heteroatom doping. We can have nitrogen functionalized, we can have boron functionalized, and all. Sorry. Okay, next, first is your how we can prepare. We are having top-down and bottom-up approach. Then how we can purify it, because once a material is prepared, it can contain some impurities. हमने उसको भी remove करना है, and for that we use centrifuge generally, and then we test exactly what are the features of your quantum dots. Now, if you are talking about packaging issues, there are some packaging issues. Active packaging, smart, intelligent packaging, sustainable packaging. We have to basically work out on all these things, and this is what we are doing with the quantum dots. Now, if you are talking about morphology, how it looks. So this is your SEM and TEM images. We can see the quantum dots. The size range is 0 to 5 nanometer. We can prepare 1-dimensional material. We can prepare 2-dimensional material. We can prepare 3-dimensional material. And nowadays, people are using metal organic framework. So this is a kind of octahedral kind of a structure, and depending upon the application, we can basically prepare different kind of materials. Okay, see in 30 seconds how we can prepare MOS2 2-dimensional sheets. Just have the powder, sonicate it. After sonication for 6 to 8 hours, we have to centrifuge it, and we will get MOS2 kind of sheets. So the process is very, very easy. Just with the help of centrifuge and sonicator, we can prepare MOS2 kind of sheets, and this is how it looks. Okay, Then we are adding it with polymers, and we are trying to make a film. This kind of film we are having, and it is having enormous properties. Okay. Now we are having bottle. This is the bottle. From this also we can basically prepare quantum dots. So what we are doing, we are using the recycled fed PET flakes and sorry. Yeah. And with the help of hydrothermal, we can do filtration, and this is how it looks like. And with the help of polymers, we can also prepare film, and this is how transparent it looks like. Another way of preparing quantum dot is your microwave process. Okay. With the help of microwave, you can speedily prepare quantum dots within a duration of 10 minutes. So that is one way. Another way is by spraying. See, we have prepared from the lemon the quantum dots, and we are spraying this on the polymer, and with the help of extruder machine, we are preparing films. So these are various kind of preparation techniques of the film. Now, quantum dots is generally in the form of solvent. Okay. So with the help of nano spray dryers, we can convert it into powder form. Here we can see how we are basically converting it with the help of nano spray dryers into the powder form. Same, it is very similar to that of milk powder. From milk, we prepare milk powder. Here also we are doing a similar kind of trend. And in extruder, we are having this kind of things. We are adding with polymers, and we are making this kind of films. And definitely it is having a lot of various properties. Now, a theme about application and implications of quantum dot in modern agriculture. So what it does, just with the incorporation of quantum dot, it enhances the crop yields by 15 to 40%. This is one thing. Photosynthetic efficiency is enhanced by 56%. Nitrogen uptake is also increased. So we can overall improve the properties with the help of quantum dots. Okay, see, this is your crop enhancer. We can see untreated crops versus treated crops. So we can see that with the treatment of quantum dots, we are having higher crop yields. This is just with the help of quantum dots. Another is disease detection. Then we are having soil moisture monitoring with the help of quantum dots, and then we are having nutrient uptake. So overall, we can enhance, just using quantum dot, we can enhance all the properties. Okay. And here we can see, we can basically do the health monitoring, seed enhancement, plant growth development, disease control, post-harvest, food safety and quality. All these things can be properly monitored with the help of quantum dots. Now, over to food packaging. What is the difference? See, first one is your traditional packaging. That means a packaging without any quantum dots. Another one is with quantum dots. And we can see the difference, that it enhances the barrier properties. It is showing transparency. It is showing good UV protection. It enhances the thermal properties, antioxidant properties, and they are having active nanomaterials. So just with the incorporation of quantum dot, we can basically enhance all these kind of properties. First one is your UV blocking. Second one is your oxygen transmission rate. We can see how the apple is looking fresh. And actually, we create a tortuous path when we are incorporating quantum dot within the polymer matrix, and it basically obstructs the flow of oxygen, and oxygen is unable to pass through the films. These are the things that we can see. Okay. Now, after doing this, we are having various kind of characterization techniques. With the help of that, we can basically analyze what we have done. See, in the first image, this is your transmission electron microscope. We can see the size range almost in the range of 3 to 5 nanometer. It shows very well aligned lattice crystal planes, which confirms the formation of quantum dot. Okay. And elemental mapping shows you your material consists of molybdenum, silver, sulfur, everything. So with the help of this, we can further confirm exactly what kind of material we are using. This is your UV blocking. We can see in the range of 200 to 400. Just with the use of 5 weight percentage, we can efficiently block 97% of UVA radiation. UVA is one of the harmful radiation that we are having. And with the help of this kind of quantum dot, we can basically block UVA radiation entering in the food. Next, we are having FTIR and XRD. FTIR is basically used to find the bonding between different kind of materials, and XRD is used to find the crystallinity nature and amorphous nature of the materials. Then we are having one more test, DSC. It is used to find the thermal technique. What is the melting temperature, whether it is increased or not, and whether the crystallinity is enhanced or not. We can see that the crystallinity increased from 38 to 45. That means that with the incorporation of quantum dot, we can further enhance. This is TGA. This is also a kind of thermal properties, and we can see that there is a shift. That means that it confirms the thermal stability becomes strong due to interaction of uniform carbon quantum dots. Then we are having tensile strength, of course, it's required. And with the help of quantum dot, we can see that the tensile strength from 18, it goes up to 66. That means that there is a 141% rise with the help of quantum dots. That means that we are having a very strong films prepared with the help of quantum dots. And we have done oxygen transmission rate, and here you can see that the normal polymer is having 8 to 10 OTR, but in case of quantum dots, it's come to 0.008. That means it is capable enough to completely block the oxygen transmission rate. And wettability is also there. SEM analysis also confirmed the tortuous path within the polymer matrix. We have further done antimicrobial tests, and it shows an enhanced zone of inhibition. And finally, we have used the chicken meat to do the storage test. And we can see that after 12 days, we can use the quantum dot kind of material films, and that is more fresh as compared to the normal polymer. And we have done pH testing, weight loss, T-bars, and TVC we have done, and we have seen that it basically controls the shelf life. And further, we have done migration test. The limit is 10, and we can see with the help of 10% of ethanol, we can efficiently control the migration of the materials. And this is all about the conclusions. We can see MOS2 sheets being incorporated by quantum dots, and it shows your efficient UV blocking, efficient OTR, and a good storage test. And nowadays, we are switching over to artificial intelligence, because in almost all the segments like nanomaterials, AI is there, and we are basically using it to optimize the things, what concentration is necessary, what is required, and accordingly we are getting the efficient results. So AI is also necessary in case of packaging materials. This is one of the paper published in food packaging. It is based on MOS2 with quantum dots. You can have a review. Another was on environmental chemical engineering. This is also PVA and AGMOS2. Here we have used silver. So this is all, and my acknowledgement to Professor Jangchul CEO, my PI there, and I'm very much thankful to the organizer, Professor Nutan Kaushik, Dr. Nishant Kumar, and other members of this university for inviting me. And this is my group there at Yonsei University, and that's all. Yeah, one thing. Koreans, they are basically fond of fresh foods. You know what is the parameter of fresh foods they are having? Any idea? Sorry. Escape. Oh. It's not working. Oh no, we have to see. This is their parameter of fresh food. This is what they have served. There was an octopus and it was all crawling all around. And once they started eating, and they are now cutting it out and they are enjoying the meal. So this is the kind of parameter they are having. Of course, it's a bit tough for all of us. So this is all about, and thank you. And if you have any queries, you can discuss.
Not then, particularly thanks to Professor Ansari for enlightening us with a great topic and with great science that evident why is top-notch publications. So once again, thanks to Professor Ansari for a wonderful talk.
Sir, आप कुछ पूछ रहे थे?
If you, one of the slides. Yeah.
in one of your slides, you saw, you mentioned the range of nanoparticles, 300 nanometers to some micrometer. About when you're talking about the, where you were talking about the quantum dot powder, you can convert into powder in that particular site.
That is basically macromolecules. If it is in the form of powder form, so powder can have a bigger size. But actually, that powder has to be disposed in water again. You have to centrifuge it out, supernatant has to be taken. That is your quantum dot. That is again the smaller size. Powder you can have in bulk.
But that powder we cannot say that is a nanoparticle, right?
That's a nanoparticle.
That's nanoparticle. So nanoparticle does not mean lesser than 100 nanometers?
Less than 100, not less than 100. Nanoparticle means 10 to 100 nanometer. Quantum dot means 0 to 10 nanometer. So you have to confine the particles within 10 nanometer range. That is your quantum dot. That's the difference. Yeah.
Next presenter is Dr. Jeffrey Bradshaw. Dr. Jeffrey Bradshaw is an entomologist, educator, and academic leader whose work integrates applied research, extension, teaching, and program development in plant health and agroecosystem management. He currently serves as the director of the Doctor of Plant Health program at the University of Nebraska-Lincoln, where he leads the interdisciplinary graduate education and workforce development in plant health. Sir, you may proceed.
Thank you very much for the invitation. Can you hear me okay? Just want to check my mic. Can you hear me okay? A thumbs up. Can you hear me okay?
Yes, sir, we can hear you.
Okay, thank you very much. Yes, thank you again for the invitation. I'll be discussing some of my thoughts on the diffusion of innovation in agriculture. Many of my comments today will be from the perspective of agriculture in the United States, but I hope that some of the information has global relevance. In this presentation, I'll briefly discuss, as author Stephen Johnson says, where good ideas come from and how we can involve farmers in the co-creation of good ideas and innovations. I'll end the presentation in a current case example from some of my work with others regarding an ongoing wheat IPM project, which I've been involved with for the past 5 years. Stephen Johnson says that good ideas come from a sustainable idea, and a sustainable idea is one that is designed from the available resources. It requires the right sort of space, and that ultimately an idea is a network. So in my work, one way that I found the right space for communication is by first earning the trust of seed sales agents, as pictured here, and then presenting ideas and findings to their grower customers who trust them. In other words, earning the trust through shared knowledge is important. With that community in hand, then I have a platform to sustainably deliver innovations to farmers. It's really about establishing and sustaining, cultivating relationships. When discussing adoption of innovations in integrated pest management, Surendra Dara in 2019 listed these 4 steps to improve adoption of IPM. One was to provide meaningful participatory training in a way that's understood by the trainee. 2 is to acknowledge each individual's contribution and pre-existing knowledge and skills. to then 3, explain how and why their actions are important, and then lastly, to maintain open lines of communication. He then further stated that too often, many of the IPM tools and techniques do not reach the implementation stage due to practical limitations, such as high cost of commercialization, such as high cost of commercialization and lack of interest in its adoption. And I would argue that if one develops an IPM tool or technology and then has lack of interest, it's because the innovator failed to sufficiently engage clientele in the innovation. So I believe one model for achieving diffusion of innovations in agriculture is through participatory research. And that's something I'll talk about here today. One model could be via intensive research, such as at the university, for example, that leads to extensive research or on-farm trialing that can then lead to adoptions of practice or innovations. A participatory research model involving farmers throughout the process could, through the lens of diffusion of innovation theory, provide opportunities for relative advantage, value and needs compatibility, minimization of complexity, extension to which innovation can be tested, and then also to be able to extend the innovation in a way that provides tangible results. So ultimately, real client engagement and meaningful communication throughout the research cycle then cultivates shared goals between broader impacts between researchers and clientele. So I'll provide an example here of one such case where we engaged farmers directly in the research. And that's with some current work that I'm engaged in, again, with several colleagues at the university, with the U.S. Department of Agriculture, and growers. The example here is the pest, the wheat stem sawfly, Cephus cinctus. This insect has been a major pest of wheat in North America now for over 100 years, with no really good solutions or integrated control options. Host-plant resistance, for sure, genes have been identified and commercialized, but alone have been found to be insufficient. However, there are 2 native parasitoids that are shown here inset next to a wheat stem sawfly, Bracon cephi and Bracon lysigaster. These have been documented as potential key mortality factors for reducing wheat stem sawfly abundance. Here's some video, hopefully it's showing up on your end, of adult wheat stem sawfly flying through a wheat field in Nebraska in June. And as you can see, there's quite a few wheat stem sawflies flying about. This is a wasp that deposits its egg within a wheat stem and then develops inside. So it's the larval stage of this pest that's the damaging stage. The larva is a stem-boring insect, and as it forms its pupal chamber and cuts the wheat stem at the base, as shown as the inset here, these small stubs that are cut almost as though by a razor blade. This cutting then results in lodged wheat, shown in the image to the right, resulting in significant harvest losses. The variety here on the left is resistant to sawfly cutting, while the variety on the right, shown laying on the ground, is susceptible. While the wheat stem sawfly has an impact on yield in wheat, it also has an impact on soil moisture potential, which is important for dryland, semi-arid agriculture. So it has an impact on other crops in rotation, as the standing residue in our region provides a windbreak that captures snow throughout the winter, which is where most of our precipitation and soil moisture is recaptured. So it has an overall impact on the system, on the overall revenue on the farm. Many growers have been incentivized, justifiably, to adopt no-till practices to conserve soil and soil moisture. However, these no-till practices also encourage higher survival of the wheat stem sawfly. So therein we have a challenge with these 2 goals for the system: wheat production and soil moisture growth increases, along with wheat stem sawfly management. So economists then have measured just from yield loss alone, or grain loss alone from wheat, up to $350 million US dollars in losses annually from just the grain losses alone from wheat stem sawfly. So a significant pest. So myself and my colleagues began a quest for, you could say, good ideas by deploying a one-year mixed methods survey to identify our, quote, innovation network in 2023. That is, we deployed a human subject survey to discover knowledge of current solutions, limitations, and potential novel solutions being explored by farmers. We also conducted small focus group conversations throughout the region, Montana, Colorado, Nebraska, North Dakota, to expand on that knowledge base and to cultivate trust. Finally, we conducted a biological survey to identify locations where the pest was most severe in that year. And one result is the map that's shown here, where we have regions that have both high human subject survey response rates and high sawfly damage. So these areas would help us identify potentially optimal spaces, again, calling back to my earlier slide, for deployment of new IPM tools and tactics toward this pest. Throughout these survey efforts, we were able to identify perceived impacts of this pest. A small number of respondents, 67, but who manage a large area, over 2,000 hectares of wheat, which in 2023 was valued between $175 to $200 million in production. We gained knowledge about their economic margins and as well as their responses to the pest, the wheat stem sawfly in this case. So we learned a number of aspects, again, about the economic features of this pest and its impact on the system, as well gleaned some insights that would help us in some of our further innovations that I'll talk about here momentarily. We also, importantly, learned about their knowledge of the role of biological control. So there was an awareness of these parasitoids I mentioned earlier, and the potential, anyway, for their yield protecting habits. We also learned about perceived management practices, best management practices that growers have explored in deploying different findings from research, certainly, but also in their trialing efforts to figure out what might work best in their conditions. So we learned about their knowledge and role of biological control and the management strategies that they're currently deploying. So through all this knowledge that we gained through the survey effort, both the human subject survey as well as our biological surveys, we were then able to co-create a solution with growers to take advantage of the tools that are readily available throughout the region and tactics that fit within the context of their production systems. We developed what we call the beneficial bug baler, which is a project to mass relocate and augment parasitoid populations from regions where the parasitoids exist to locations that have had challenges in sustaining populations of these parasitoids. I noted the parasitoid earlier, a couple species of bracon or braconid wasp. The adult wasp, shown here in the middle, is able to locate the wheat stem sawfly larva that's hidden within the stem. She then stings and paralyzes her sawfly host by piercing through the wheat stem and into her host. Then she lays an egg near the host, and once the parasitoid egg hatches, the larva, as you can see developing here on the left side of the image, is paralyzed, and then that larval host consumes and grows within that wheat stem. The parasitoid larva eventually pupates inside the wheat stem. You can see that shown on the right side of the image. And when the adult stage emerges, it chews a hole, an exit hole in the side of the wheat stem and flies off, shown inset. Both research in our lab and other labs that have been published has shown that parasitism rates that are at 50% or greater can facilitate the recovery of grain weight losses from the sawfly. So this is excluding losses from lodging, but just the losses that are due to reduce seed set, and reduce seed weight. So just looking at these two images, the figure on the left, where we have softfly infested tillers, we have a certain head weight. And then the uninfested tiller to the right, you can see that that loss is about 40% yield loss due to wheat stem softfly, again, in grain count and weight. And then we have the parasitoid when it's present and attacking the wheat stem softfly. You can see in the middle bar, essentially fully recovering that yield potential. So great impact potential for managing the wheat stem softfly if we could only find a way to secure reliable biological control in these systems. However, previous biological surveys for parasitism levels throughout the region had shown only 20% of fields exceeded this 50% threshold that's important to recover that yield loss. Or in the case of Colorado, particularly, parasitoids have been completely absent in wheat fields, even though they can be found in grasslands. So again, the aim is to harvest a portion of the parasitoid population from some farms and move them from those farms into regions where we have farms that have less than 50% parasitism. So researchers and participating growers then work together through this project, kind of the process was kind of outlined here on this slide, to develop a stepwise approach to identify sites where there's high parasitism, harvest the parasitoids from those locations by baling wheat straw that contains the parasitoid but does not contain the pest, transporting those bales, and then spreading the bale straw at destination fields.
Professor Jeffrey?
Yes.
We are running short of time. If you can save the time, then I'll highly appreciate you. Please wrap up within 3 minutes.
Okay, very good. Thank you. So we're able to move these bales from locations where the parasitoid was in high numbers to locations in Colorado where they were lacking. The project was very successful. The pilot was able to release 7,000 to 10,000 parasitoids per 136 kilogram bale. The parasitism rates were then able to increase around 50% in Colorado in 2025, where they had 0% previously. And so word spread about this success throughout our innovation network that we had identified, and interest continues to grow among farmers who participate now in their own trials. So real quick here, lastly, I would just say that through this process then we've engaged in efforts to understand how to design better landscapes to conserve the parasitoid, as well as working with various federal partners that have roles in certification, crop insurance, trial funding, or other cross-connected conservation programs. So then lastly then, to wrap up this talk, this work has been strongly supported by the University of Nebraska, Colorado State University, the Colorado Wheat Commission, and the Nebraska Wheat Commission, as well as the USDA. So again, I want to thank you all very much for your attention, and please consider farmer participatory research as a route to adoption of innovations in plant health. Thank you very much.
Any question from the audience? I mean, quickly, if anyone. If not, then I'll previously thanks to Professor Jaffrey for enlightening us on the aspects of how we can use the microbes for saving the crops, fruits, vegetable, flowers, and all that. So really, it was a very wonderful lecture. Mostly the student benefited from your lecture here in this institute. I appreciate your effort, and it's a very hard time in years, and you are sitting and delivering the lecture. That's a great thing. Once again, I thanks you.
Thank you very much.
Thank you, sir. And our next speaker is Dr. Anveshika Singer. She's the founder of MIHISO, which is an abbreviation of Mind, Health, Soul, a D2C health food brand focused on convenient, clean, and nutritious breakfast solutions. With a PhD in plant biotechnology and no formal background in business, she transitioned from research into entrepreneurship, building Mihiso from the ground up into a fast-growing consumer brand. Anveshika? Yep, please.
Hello. Hello, everyone. I thank you for the opportunity. It's really great to be here. And so I'm Dr. Anveshika. I'm the founder of Mihiso. It's the short for Mind Health Soul. And it's a new age D2C startup focusing on healthy, clean label products in breakfast cereal and snacking industry in India. And this is my story. This is my journey from working in a lab to building a breakfast cereal brand. So I did my BTech and MTech from IIT Delhi, and I continued my MTech research into a PhD. It was in plant biotechnology, and my research area was production of secondary metabolites from hairy root cultures. I have 2 patents in the field, and I must admit I don't have any background in business. I have no formal training, no formal education. Nobody in my family has ever done business. They come from academia. And but being from having a research background has helped me in developing a scientific mindset and having an eye for detail, which has really helped me in during the R&D and the product formulation phase of our journey. So this is how I started Mihiso, the journey where it all began. So when I finished my PhD, I got pregnant. I had to take a break. And by the time I was ready to start my career again, then COVID hit the country. Everybody was under lockdown. And it was during that time people started to make better health choices. They became more health conscious. And like everybody, we were also looking for healthy options, which were, which were convenient to have in the lockdown situation, which doesn't take a lot to prepare and which should be tasty enough to inculcate as a habit, to inculcate in a diet for a long term. And that's how we stumbled on the recipe of overnight oats. It's what we are known for in the market. Overnight oats is a Western concept, and we were the first ones to launch it in India. And we used to prepare overnight oats during lockdown period. We then started to develop the recipe, get the formulations right. And slowly, after repeated trial and errors, after months and months of R&D, we launched it around 3 years back. So what exactly is overnight oats? So how is it different from the regular oats? So it's actually...
Good topic. Don't devote much time on introduction. Please save the time. So time for you is only 5 minutes now.
Yeah, sure. So overnight oats is actually a scientifically proven research-backed phenomena where soaking the oats overnight in milk, it helps in better digestion. It reduces phytic acid, it maintains nutritional integrity, and it is actually high in resistant starch, which acts as a prebiotic in the gut, which keeps us full for long. And since it does not involve any cooking, the heat-sensitive nutrients do remain intact. So during the journey, these are some of the challenges we faced was selecting the flavor. See, in the market, the most prevalent flavor option available was chocolate, and we didn't want to just limit ourselves to chocolate. We wanted to expand to other flavors also. So we launched in different exotic flavors like mixed berries, banana caramel. We recently launched rose Thandai flavor, for which we used to source the rose petals from Kannauj, which is the most fragrant rose variety in the world. And then while choosing the ingredients, we saw that the other brands, they were using candied fruits, which is actually sugar laden and tasteless, sugar laden and cheaper alternative. So we decided to switch to fruit powders, spray dried and freeze dried fruit powders, which actually gives a better taste and gives a smoothie like consistency to the breakfast while we have it in the morning. But the problem with using the fruit powders is that it is hygroscopic in nature. So it sticks to the plant where the manufacturing is going on, which leads to a lot of wastage. So we had to figure out and maneuver some challenges related to the manufacturing. We had to develop a process where we could fuse the flavors, the powders and oats together to give a consistent and uniform taste in every serving. So we thought that getting the product right, focusing on the product is going to be everything, but that is wrong. That is so not true. Actually, what matters more is that how you get the customers to trust you to try a new brand. And we thought that we play by the play, we'll go by the playbook. We have a set of rules, we'll go by it, and we'll see some growth happening. But that's not the case. Every brand, every startup has a different roadmap. They go through different challenges which they navigate on their own. And we thought the customers are going to love it because we had confidence in our product. But customers, everybody has subjective taste. The feedback was mixed, so we had to iterate and relaunch it. And the most important was that we thought that once our sales start, when the sales will start, the money will start flowing. But the money, that whatever money we made, we reinvested it, and there were periods where we really stretched and we had to make with limited resources. So there's a lot of myth going on with how a brand and how a startup works. So we could get the product right. Actually, getting a product right is the easiest part. What is the hardest and the real challenge is getting your customers to try it, to have a trust in you and to come back for you. That is actually the real challenge. And it was really challenging to get the first 50, 100 customers, to getting them to try an unknown brand, to develop a trust. And the feedback was sometimes very harsh, but it really helped us in iterating and getting the formulations right. And then since this is a new concept, so customer awareness was equally important, which we were during the starting, which we underestimated the role of marketing, the role of customer awareness, which really helped us when we started it.
Vishka, already you have taken up allotted time, so please come to conclusive remark of your talk, please.
Sure. So listening to customers really helps us. It helps us in improving the product. It helps in building the trust, and that over a period of time, it has really helped us. And today we have served over 1 lakh customers. We have 4.5 rating on Amazon. We have more than 5,000-6,000 reviews on our website. And recently we pitched and got funded on national TV show Idea Buzz. It came on ZTV. And the 3 key lessons that I want a budding entrepreneur to take away is that ideas don't matter as much as execution. Ideas will remain ideas only until you execute. And you don't have to keep everything figured out before you start. Everybody's journey is different, and clarity often comes after you begin, not before. And most people, they wait too long. They don't execute, they don't start it. And the one final thing is that you don't need a perfect idea, you don't need a perfect plan, you just need to start, and the rest you will figure out along the way. Thank you. Happy to take on the questions.
Like as a tissue cultivation, what are the major problems which you face?
As a sorry? You're not much audible, sorry.
What are the major challenges which you faced, and how did you overcome it?
See, the major challenges was getting the customers to trust you. Since this is a new concept, India is a hot breakfast country. The people don't generally eat cold breakfast. So getting something new for the customers to try, that was a hard part. Creating an awareness in a country where nobody knows the concept of overnight oats. That was one of the challenges. Second challenge, as a woman, especially traveling to the manufacturing site, especially during the late nights, it's challenging. And yeah, I think these two cover the most of it.
So that was an interesting session. So we had 2 keynote addresses and 1 invited talk. And now I would like to invite Dr. Priyank for a vote of thanks.
Good evening to all of you, and thank you for this insightful and inspiring validative session on the HOTI entrepreneurship and startup stories. And this session featured the outstanding keynote address by including our Dr. Jamil R. Ansari, the talk on the hybrid nanotechnology in food packaging for extending the fresh produce shelf life, and Dr. Jeffrey Bradshaw, insights on the co-creating the innovations with farmers for sustainable agriculture, and invited talk by Dr. Anvisha Singhal on the building a brand from the lab to market. And our gratitude, special thanks to the session chair, Dr. Ram Asre, and our DG ma'am, Dr. Nutan Kaushik ma'am, our co-coordinator, Dr. Abhishek Sharma sir, and reporter, Dr. Nikhil Chandel and Dr. Chaitra, and all the speakers for their expertise and engaging presentations. Your contribution enriched the discussion on the entrepreneurship, technology, and sustainability in the horticulture and horti entrepreneurship. And this session motivates us to drive innovation in the horti business startups and looking forward for the future collaborations. Thank you and have a nice day. Thank you, sir.
As the session concludes now, I request Dr. Nutan Kaushik ma'am, our DZ ma'am, to kindly felicitate Dr. Ramasre.
May I request our beloved director, IRI, Indian Agriculture Research Institute, Mr. Rao, please join us. Thanks, sir.
ये चरानी करो, चरानी करो, रुको रुको रुको, करना तो चाहिए इसको, करो तो सही, हाँ ये करो, वो कर दो, कम कर दो इसकी आवाज, 0 0 0 0, ये वैलिडिटी सेशन में चला देना, ठीक है, ये वैलिडिटी सेशन होगा, बताओ ना। मैंने बनाया हुआ है पूरे इवेंट इसको बंद कर दो, आवाज मत सुनाना। मैम ने बोला था कि पूछ लेना मैम, हाँ सर वैसे पूछ लेना मैम से पहले मैम
पोस्टर देखो पोस्टर पोस्टर देख लो
So, good afternoon, everyone. Once again, a very warm welcome. We now move towards the valedictory session and award distribution ceremony, marking the formal closing of ICRAHOR 2026. Before we start, may I request all our esteemed dignitaries to kindly take their seats on the dais. Please, sir. A very warm welcome to the valedictory session of the International Conference on Recent Advances in Horticulture, ICRAHOR 2026. It is indeed a moment of pride as we reflect upon 2 days of insightful discussion, knowledge exchange, and innovative ideas shaping the future of horticulture. To begin this session, may I respectfully invite Dr. Nutan Kaushik Ma'am, Director General, Amity Food and Agriculture Foundation, to present the summary report of this conference. Ma'am, please.
Hello. A very good evening to all of you. and respected Dr. Rao, and the Director General from NABARD, and Honorable Founder President, sir, our Chancellor, sir, Vice Chancellor, Madam, and on my own behalf and behalf of all my colleagues, I welcome you all to this, the last session of the conference, which is the valedictory session. During this conference, we had 5 thematic sessions, and we also organized a competition called Hortipreneurship. So the conference started with entrepreneurship, where we had 8 presentations, and our students from our students from Masters of Horticulture and Post-Harvest Technology, they had developed some products and they had also conceptualized some ideas. So they presented their ideas for the startup ideas, and the conference started with the entrepreneurship competition. So 8 students presented their ideas, and it was judged by our none other than Dr. Thapa, Dr. Thapar, who is here, and Dr. Dubey from IIP, and Mr. Dr. Kamal Kumar and Dr. Meenakshi Singh. So they all evaluated the ideas, and they all appreciated the ideas. They were very, like, ideas were from waste utilization, mainly focusing on the waste utilization and how to develop the biopesticide and so on for the protection of the diseases for the horticultural crops. And so today we will be announcing the winners of those competition. And this was followed by 5 thematic sessions, and we had 20 speakers, and about 15 speakers from the international speakers and 5 the national speakers. Due to this geopolitical situation, they could not join personally, though 5 had earlier confirmed to join personally, physically, but they could not join because they had to cancel this one. So all the international speakers, they joined in online mode. But it was a very useful discussion, very thorough discussion, and the themes, it varied from right from breeding the crops for improvement of the horticultural crops, their biotech, abiotic, and nutritional quality, and then followed by the value additions, how we can do the value addition, processing, and so on, and then the digital horticulture, how the digital age, the AI, and all that can help in the area of horticulture, be it production, be it post-harvest, or be it processing. So they were very good presentations which were made. And then this was followed by today's session on climate smart agriculture. So that was their presentation, and then ended with the horti entrepreneurship, like invited talk on the horti entrepreneurship. So in all together, we had 20 presentations, and we had 50 oral and poster presentations. So we will also announcing the winners of the oral and poster presentations today. So overall, it was a very good summary. So this was, so in all, and the recommendation of this conference will be taken forward either in terms of the policy matters, which will go to the funding agencies, the policy makers, or the research agendas for the scientists, which will also be communicated to the funding agency. So these are the new emerging areas where the funding agency should focus on. And then we will also be publishing the proceedings. The selected papers will be published in Scopus and Web of Science indexed proceedings. So we will be inviting the full-length paper from each one of you. And those which are selected after the review will be published in Web of Conference series, which is a Scopus and a Web of Index. So I thank each one of you who have participated, all the speakers, for giving their valuable times, and despite their busy schedules, some of the speakers today, there were 2 speakers from US. They were sitting online till 2 a.m. So this shows that how much dedicated they are, how much for this their subject area where they are, and how they care that whatever they have learned, how to pass it on to the younger generation, and how to discuss among the scientific community. So this shows how committed they are for their field. And so despite fighting with the odd hours. And and there were a lot of discussions happened during this conference, and I'm sure that this conference will bring a lot of networking
not only with the MIT, but also with those who have participated in this whole conference, and the new project ideas, new publication ideas, new joint research ideas, which will lead to the successful and successful culmination and the new knowledge which the students have gathered. So with this was the basic idea, and I hope that we have met the 100% the objective of the conference. Whatever we have conceptualized as in terms of the objectives of the conference, I think we have met those objectives, and and I thank each one of you, especially the funding agencies, funders, and the sponsor, the Dhanuka and RAR Life Sciences, and our publishing partner, Agriculture Today, BioWeb of Conferences, and our media partner, Agriculture Today, for supporting this idea. And this is third in series, and the fourth we will be conducting somewhere in 2028 now. So we look forward to seeing you all in 2028 with the whatever you have learned here, and we wish to see the outcome of that in 2028. Whatever you have learned, how you have implemented it, and how you will that in terms of the presentations and so on. I'm also thankful to Sir Dr. Rao that he accepted the invitation. I'm thankful to Manish for bringing him here. So thank you, Manish, for because he was the one who was interacting with you and confirming your presence. So we are so grateful that you accepted our invitation. Dr. Navin Kumar Roy could not, Mr. Navin sir could not join because he has been called by on urgent meeting because nowadays the government is very active. So everybody can be called anytime. Yesterday you have seen that Prabhat Kumar ji, Dr. Prabhat Kumar, Agriculture, Horticulture Minister, he was held up with the minister and we had to wait for 50 minutes for his address. So thank you. But he made sure that he sent his Sameerji, sorry. Sameerji, he sent Sameerji over here so that he can fill the, so he can represent the NABARD here and then provide this insight. So I'm thankful to you, sir. And I'm looking forward to the great interaction with during this whole conference. Though we have prepared a small film showing the glimpses of the conference. Probably I'll request Priyank if you can show that film to all of us. These are some reflections, I think. Sharing session. Sound it on you? नहीं साउंड नहीं करनी
साउंड यहीं का ये उसका
नहीं है इस साइड साउंड नहीं है
साउंड है ना
अच्छा 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 ओके ठीक है the sound is there, but somehow it is silenced. So we are going back to the old ages silent in modern era with seeing the movie in silent mode. So this is our inaugural session, which you can see over here. Our founder present. He was, and then this is our session. Okay, lunch bhi dikhaya. Okay, very good. And these are some of the sessions going on. Session 1, poster session. We were session 2. I think yesterday we had the session until 7:30 p.m. So, and today's morning session.
This was the oral presentation, online presentation, oral report. That's all. I think we can just skip it. Thank you so much. Thank you everyone for the participation. And I look forward to your participation in 2028. Thank you.
Thank you, ma'am, for the comprehensive overview. It is my great privilege to introduce our esteemed dignitary, Dr. Tirukumalai Srinivasa Rao, a distinguished leader in the field of agricultural sciences and currently serving as Director and Vice Chancellor of ICAR, Indian Agricultural Research Institute, New Delhi, since 2024. Sir is a renowned expert in soil science and climate resilient agriculture with significant contributions in the area of soil carbon sequestration, climate change adaptation, natural resource management, and sustainable agriculture. He completed his PhD from IARI and further strengthened his research credential through postdoctorate work at Tel Aviv University, Israel. Prior to his current role, he served as the director of ICAR, National Academy of Agricultural Research Management from 2017 to 2024, and earlier as the director of ICAR, Central Research Institute for Dryland Agriculture from 2014 to 2017, where he played a pivotal role in strengthening research and institutional development. A recipient of the prestigious Professor M.S. Swaminathan Award for 2024-2025, Sir has been widely recognized for his outstanding contributions to climate resilient farming and agricultural innovations. In his current capacity, he is leading IARI towards excellence by fostering cutting-edge research, promoting lab-to-land initiative, supporting every startup ecosystem, and advancing sustainable solutions to ensure food and nutritional security. It is truly privileged to have such an eminent personality in our midst. With these few words, I respectfully invite Dr. Rao sir to kindly address the gathering. Please, sir.
Good afternoon, everyone, and thank you for bringing me here, and Dr. Manish and Madam Nutan. She was, I think, my batchmate senior at IRI, and Dr. Manish is, we are in one team working on various environmental and soil issues. I feel happy to see that Amity University is organizing a national conference on horticulture. Really appreciate. And IRI is, I think, amply reflected. I'm seeing a large number of students here, and also our colleagues, and also, of course, the director of IRI. This resembles that perhaps we need to work more closely, Amity University and IRI, for the cause of farmers. We have in India 14 crore farmers and 15 crore farm holdings. And the agri sector is contributing very, very critically. It's not only now, currently agri contributing GDP of 19% GDP. During COVID, when all other sectors down, agri sector GDP was 21%. The success story of Indian agriculture is very, very tremendous. And for that, thanks that Amity University also contributing equally in the form of horticulture. Just 75 years back, we were begging the food. Most of our money was spent on import cost of the food. People were looking very down upon us. But now today, India is producing around 360 million tons of food grains, equal amount of horticulture fruits, vegetables, and cut flowers, 200 50 million liters of milk, 110 billions of eggs, 19 million tons of fish. In fact, we don't have storage capacity of keeping rice and wheat to some extent. But it doesn't mean that it's not only food, cereal diet. Now, recently, National Institute of Nutrition and Indian Council of Medical has emphasized that daily requirement of cereal has reduced, and the ICR estimation is that by 2047, when we complete 100 years of Indian independence, horticulture production requirement is the highest. You know, dear students, currently rice production is 160 million tons. By 2047, we need just another 70 million tons of rice. Wheat, maybe another 50-60 million tons of wheat. But you know, horticulture, currently 250 or approximately 300 million tons. Country's requirement is around 1,000 million tons. So what it means that nutrition is a very, very critical factor. Consumer preferences are changing and moving from cereal diet to nutrition enriched. When nutrition security and sustainable development goals means horticulture commodities, whether vegetables, fruits come into the picture along with the dairy sector. So what to do? There are many things. Doesn't mean that we have, I'm telling so much proudly success story. Still, India has a lot of people who are hungry people, not having even minimum energy requirements, leaving aside the horticulture fruits and vegetables. When we take about horticulture, we have difficulty. One is that our production is very, very low. Still, yield gaps are existing largely. During crop season, climate change is another important. You know, currently, last week, heavy rains, lot of wheat crop was, in fact, you can see unseasonal rainfalls, and vegetable crops, fruit crops are highly vulnerable. We are very happy that mango flowering is very high this year. But during last 3 days, 4 days back, heavy rains and heavy wind, almost you can see that if in your university or nearby areas, how much fruit drop is there. So nothing is guaranteed sector in the light of climate change. So what's supposed to do is another important to bridge the yield gaps despite of climate change. Another important is having 350 million tons of fruits and vegetables. Around 30% is a post-harvest losses are there. Perhaps I was listening 1 or 2 presentations of value addition processing. IRI is supporting around 500 agri startups with larger budgets with different ministries, including NABARD. And first of all, how to reduce vegetables and fruit losses, how to improve the production yield gaps, and how to bring that when climate change repeatedly is telling that how climate resilient varieties can be developed, are being developed. IRI recently, Honorable Prime Minister visited IRI. He released 110 climate resilient varieties. Out of that, including vegetables, IRI varieties, around 11 varieties were released. Horticulture has become very, very important focus for many governments, India, many other countries. On 1st April, IRI celebrated 122nd Foundation Day, where Honorable Chief Minister of Delhi, Madam Rekha Gupta ji was the chief guest. She was talking that how new innovations in horticulture, because some of the horticulture, you know that the pesticide load in agriculture and food is around 3 kilos active ingredient. If we take horticulture crops, fruits, vegetables, we don't know, one side spraying happens, other side tomatoes are harvested, nicely come to the supermarkets, happily we eat. Similarly, grapes. I tell you, all the students, grapes and these things, never eat when you are purchasing. Heavily pesticide loaded. Point is that how to produce safely, despite of lot of huge damage for pesticide in pests and diseases. Recently, ICR has estimated that what is the loss of pesticides, insects and pests is around 7 lakh crores annually. The loss due to pest and diseases is around 6.5 to 7 lakh. So one way we have, because of climate change, because of various reasons, pest and diseases, we have to apply to produce more, but consumer preferences, health issues, we need to control and need to reduce. So there is always the sustainability aspects are there, and farmers are very much interested in horticulture systems. We're also advocating in agri system, go for high value crops, move from rice and wheat to some extent, and go for towards farmers' income, the high value crops like fruits, vegetables, like mushrooms and many other commodities. But telling is easy, doing is very difficult. They need supporting systems, financial, market, technical mentoring, financial mentoring, business mentoring, and overall policy support. When all these things are converged, perhaps that what we anticipate that sustainable and agri horticulture system evolve. There are many technologies. Of course, IRI, some of the students who are working in highly protective cultivation. When we are talking about climate resilient agriculture, climate horticulture is very vulnerable to this thing. We are looking forward for protective cultivation. IRI has different models and a lot of government subsidy is there. Huge subsidy. In fact, we all need, including students, all the colleagues who are sitting here, there is a strong campaign that what kind of support systems government is having. We have all the system like waste to wealth, sprinkler irrigation, micro irrigation, vermicompost, whatnot, anything. Even agri startups, huge budgets are available. Maybe Startup India, Stand Up India, NABARD, and different, all private banks, in fact, many institute, Niti Aayog, everybody is supporting. I think we need to keep aware that the funding support, without money, it will not move. Another thing important is that kitchen gardening. It looks very simple through horticulture system. Out of 10 women, 6 are anemic, 5 to 6 are anemic. Women health, especially in Indian culture, very important, because we all know traditionally in the villages, not in Delhi and Noida, if mother takes food enough, sufficiently balanced food, we can feel that entire family is taken, because children are fed first, guests are fed, men followed by. And girl health is so important because they are the future mothers also. So any anemic children, anemic daughters, I think that one way I think compensatory that a kitchen gardening. It looks very small. What are you talking about kitchen gardening? Simple 2 rows of palak, 2 rows of methi, 1 pomegranate, 1 gawa, 1 papaya. It looks very simple when IRI is giving a small kit to the farmers, but it makes altogether different. Anybody is growing, if any tree is there, purchasing is difficult, but any tree is there in the household, certainly they consume more. So my best wishes to all of you for making so many innovations. And there are many. I spoke about protective cultivation. And another important is food losses, especially horticulture losses, is that India has a lot of airports. I think maybe around 200, 300, maybe 400 airports. And horticulture production is so much. I think from Hyderabad, where I come, within 2 hours we can capture the Middle East market. From Chennai to Bhubaneswar, we can capture in East Asia markets. When Sri Lankan food crisis are there, I think within half an hour, 40 minutes, Chennai market train comes. I think new thinking has to come that, and there are plenty of opportunities. And to reduce horticulture losses, simply nano-coated things are contributing that moisture loss reduction. Similarly, I was addressing one of the group of youngsters at Tirupati Balaji. There are almost, of course, those in ICR and Agriculture University, the meetings are in big melas. Maybe around 2,000 students were there. In Tirupati, every day there is a lot of organic waste, about 10 tons per hectare, 10 tons per day in terms of offering fruits, offering flowers, and also prasad, which are the bioplates are given. So what to do? That can we call them as a holy waste? That can we go for as a organic production, convert into biochar and any other things and grow for these things? I think these innovations, I think new generation students can come and do. And I wish you best wishes to all of you to see that since I believe that many of you are continue to work in horticulture, and horticulture is a critical requirement to meet the Indian requirements and the world requirements, but lot of innovations are required. And let us work together, perhaps in the welfare of the farmers. I don't know how many of these youngsters have seen a rice plant. I was interacting from youngsters in the school, where is the rice is grown? That boy smartly and cutely told that in the supermarket. The current generation, perhaps, I don't know, Amity must be better, I'm sure. So how many have seen these plants, how they have talked to the plants, how they have played with the leaves and the roots of the plant. So when you feel that emotionally with any crop plant, then only you can do the outstanding research and advance of any research, plant research. Thank you very much and God bless you.
Sir, thank you so much. I would like to inform that at MIT we don't not only have the horticulture, we also have agriculture. So we have MIT Institute of Organic Agriculture and MIT Institute of Horticulture Studies and Research. So last year to 2025, we were ranked in number 15 in NIRF ranking. So that's I wish to say. And MIT being a research and innovation driven university, so research and innovation is the key aspect of our this thing. So maybe we'll invite you some other day, both of you, and then have a detailed discussion later on and informing about the MIT, what MIT is doing in the field of food and agriculture, sir. Thank you so much, sir. Thank you for your giving your time. Thank you.
Thank you, sir, for your wonderful and insightful address. With great respect, I now invite our next guest of honor, Sri Samir Athalya. Currently, sir is serving as Deputy Manager at NABARD New Delhi Regional Office. Sir joined NABARD in 1996 and has worked across several regions, including Mumbai, Lucknow, Bhopal, and New Delhi. With over 3 decades of experience in rural development, banking, human resource management, credit planning, tribal development, and climate change, he also presents NABARD as a board director at National Minorities Development and Finance Corporation. With this brief overview, I request sir to kindly address the audience. Thank you, sir.
Good evening, everyone, and congratulations on your presentation of your papers and exchange of your ideas. Last 2 days, you must have exchanged a lot of ideas in the area of horticulture, new areas in the horticulture. Horticulture presents a huge potential for upgrading the incomes of farmers, especially for small farmers and marginal farmers.
and it has got huge potential for post-harvest management and this thing food processing. So in horticulture, if R&D research and development is done, and if this research is taken to the grassroots level to the farmers, this will play a huge role in increasing the production of horticulture produce. And basically, we feel that at NABARD, we are supporting various research institutions in various areas. We are supporting various ideas where we are taking farmers to the various progressive farmers to the fields and help them in understanding the various new technologies so that they can take up the new ideas. As well as we are supporting various startups also. I request all of you to give focus to two points, mainly in case of horticulture. One is see to it that if you can, whatever research you are doing, if that research reaches to the small farmers and marginal farmers and they are benefited from it, it will help to a large extent to the increasing productivity of the horticulture produce as well as increasing the income of India. Further, climate change is playing a vital role in reducing the various productivity of various products, including horticulture. So, if the climate change issues are addressed in any of your research, that will play a great role in helping the farmers in the help producing this horticulture produce. In NABARD, sir, we have one tribal development project where we are supporting tribal farmers to develop one acre of horticulture, 1 acre of agricultural land and develop a horticulture orchard. So first 3 years normally, since the horticulture produce is not available, we are supporting them in the kind of intercropping. And after once the 3 to 4 years, they get the horticulture produce and they can start earning from that. Basic intention is that they are self-sustained and they start earning something from that 1 acre of land. So the whole project is for tribal community and it is completely on 100% grant basis. So I request all of you to do some research in this way, that so that the small farmers, marginal farmers, and these tribals who are not having any access to the new technologies, they are benefited at a low cost with low cost technologies. And thank you everyone, and I wish all the best to your future. Thank you.
Sir, I would like to say that ABT is hand-holding 7 FPUs, and 2 of the FPUs are tribal-based in Dhanbad. Probably this could be a good scheme for them to utilize, and probably Nishtha is there. Nishtha, please take care of this. We'll submit a proposal to them for this one. And another thing which we want to seek the help of the Dhanbad is in taking the agrivoltaic further. Amity has developed the agrivoltaic system. It's a dual land use system. We have the same land, we can grow the crop and we can also generate the electricity, and that could be another thing beside the other multiple things. So we will be in touch with you, sir. Thank you so much. This was such a wonderful eye-opener because I think the awareness is very key to for the development of any sector. So thank you so much for making us aware about this scheme. Thank you, sir.
Thank you so much, sir, for your motivating and thought-provoking address. We now move to the most awaited segment, the award distribution ceremony. This award recognizes the dedication, innovation, and excellence demonstrated by our participants. So for this, may I request our Dr. General Ma'am, Dr. Newton Kausik, to kindly announce the awardee. But please wait for a few minutes. Right now, our colleagues are writing up the name.
You can display the certificates, Anamika. So we have digital certificates available. So I'll request Dr. Rao and Sameer to come forward. And when the this winner is announced, they can come forward and then please click the pictures with our dignitaries. So, but this certificate will be online. Okay. So we will start with the with the pitch competition, pitch. Yes. आप पूरा full कर दीजिए. Good. तो विनर से स्टार्ट नहीं करना, आपको रिवर्स में करना. यहाँ से मैं बैक चल जाऊंगा. यहाँ से बैक चल जाऊंगा ना. So we'll start with the third prize winner for the pitch competition, Miss Jyoti Tajo. And Rajkumari Devi, both. Yeah, please come here. You can announce the prize. I will be there with them.
The third prize in the pace competition goes to Miss Rajkumari Janit Devi and Miss Jyoti Tajo. So everyone, please give a big round of applause. Jyoti Tajo. Rajkumari Janit and Jyoti. Yeah. The next second prize goes to Miss Rinky. Miss Rinky. Ma'am, I think she is not here. So we'll go to the first. The first prize goes to Miss Gural Patanjali and Miss Isha Kumari. Oral presentation. So we move towards the oral presentation. The oral presentation, the third prize goes to Oktijalia and Miss Tanvi Bor. Oktijalia.
Yes, I'm here.
They are online. So we go to the second prize, Mr. Bharat G. And the first prize of oral presentation goes to Miss Sananya. Now moving to the poster presentation, the third prize goes to Mr. Subham Tagya. Mr. Subham Tagya. Jagya? Sorry, Jagya, mispronunciation. The second prize of poster presentation goes to Miss Rashi, PhD scholar of AIHSR. And the first prize goes to Mr. Bharat from IRI. Congratulations to all the winners. And to those who are participated, we will be handling the certificate online through your mail only. Yes, ma'am. Oral हो गया, poster हो गया, fix हो गया. All the winner kindly come forward so that you can have a group pictures with our dignitaries. Everyone please come forward, the winners. For the participant, we will be sharing the certificate. All the participants, students, faculty, please come and join for the photo session. All participants, faculty, student, please. Just sit down, please, for the water side, please. Congratulations once again to all the winners for their outstanding achievements. Your hard work, innovation, and dedication are truly inspiring. We also appreciate all participants for their enthusiastic involvement. Every effort counts. Let's give a big round of applause to everyone for the participant also. So before the formal board of thanks, may I request our DZ ma'am, Dr. Newton Kaushik, to kindly felicitate our guest of honor, Dr. Srinivasa Rao sir. And also I request our DZ ma'am to kindly felicitate our guest of honor, Sri Samir sir. As we come towards the formal close, may I invite Dr. Anamika Verma, Assistant Professor AIHSR, to kindly deliver the vote of thanks. Respected Chief Guest, Guest of Honor, distinguished dignitaries, honored of the dais, eminent speakers, honored delegates, faculty members, dear participants and students, a very good evening to all of you. Myself, Dr. Namita Verma, Assistant Professor, AIHSR. It is my proud privilege to propose the vote of thanks on the successful culmination of the prestigious third international conference on recent advances in horticulture research 2026, organized by Amity Institute of Horticulture Studies and Research in collaboration with Amity Institute of Organic Agriculture under the aegis of AFAF. At the outset, I extend my deepest gratitude to our honorable chief guest and guest of honor for gracing this occasion and for their enlightening addresses. Their words have not only inspired us but also provided valuable direction for future research and innovation in the horticulture and allied sciences. I express my sincere appreciation to the visionary leadership of the university, our honorable chancellor, vice chancellor, and esteemed patrons, whose unwavering support and encouragement made this conference a grand success. I would like to place on record our heartfelt thanks to Dr. Nutan Kaushik, chairperson and convener of the conference, for her exceptional leadership, meticulous planning, and constant guidance throughout the event. Our sincere thanks to all keynote speakers, invited speakers, session chairs from reputed national and international institutions. The conference witnessed intellectually enriching sessions on themes such as breeding and biotechnological innovations, digital horticulture, smart farming, post-harvest management, climate-resilient practices, and horticultural entrepreneurship. Each session added immense value and broadened our perspectives. I take this opportunity to especially acknowledge all session coordinators. Their dedication, coordination, and academic commitment significantly contributed to the success of technical sessions, ensuring meaningful discussions and knowledge exchange. We also extend our gratitude to all judges, panel members, and rapporteurs for their thoughtful evaluation and constructive inputs, especially during the Young Entrepreneur Pitch Competition, poster presentation, and oral sessions. I would like to appreciate all the participants, researchers, academicians, and students whose enthusiastic involvement and scholarly contribution made this conference truly dynamic and interactive. A special word of thanks to the MCs, Dr. Gautami and Dr. Devi, who ensured that every segment of the program from the inaugural session to the valedictory ceremony was conducted smoothly and professionally. I also extend my sincere appreciation to the organizing committee, faculty members, and administrative staff for their relentless efforts behind the scenes. This dedication in handling logistic, registration, hospitality, and technical arrangement ensured the seamless execution of this event. My heartfelt thanks to the student volunteers of AIHSR and AIOA, whose energy, discipline, and commitment played a crucial role in managing the event efficiently. We are also gratefully acknowledge the support of all collaborating institutions, sponsors, and partners who contributed to the success of this conference. I would also like to take a moment to acknowledge all those individuals whose name is not on the list. Their names have not been mentioned explicitly, yet whose contributions have invaluable to the success of this conference. Behind every well-organized event lies the silent dedication of many committed individuals, faculty members, administrative staff, technical team, and support personnel who worked tirelessly, often behind the scenes, to ensure that every detail was executed flawlessly. Your hard work, sincerity, and unwavering commitment have not gone unnoticed, and we deeply appreciate your efforts. As we conclude, we take with us not only the knowledge shared, but also the spirit of collaboration, innovation, and commitment towards sustainable horticultural development. Once again, I extend my gratitude to each one of you for your valuable presence and contribution. Thank you all. Thank you, ma'am. And we officially conclude the ICRAHOR 2026. I extend my heartfelt gratitude to all our respected dignitaries, speakers, participants, and the organizing team for making this conference a grand success. So we now invite you all to join for the high tea and continue the networking interactions. Everyone, please be seated, please, for a moment. So everyone, please be stand in your position. So now we will be playing a national anthem. Amen. Thank you. Now we can proceed for the high tea.